Good afternoon. Thank you for joining us. So we are happy to have you here in this workshop where the SEMIC LDES team is going to talk about building sustainable interoperability strategies. Before we start, I'd like to introduce myself. My name is Anastasia Sofou, and I'm a member of the SEMIC LDES team. I joined the team quite a few years ago, I think, when the team started to take shape, and I'm really, really happy that I'm part of this team. First of all, because we have Pieter, which is very enthusiastic, and he makes things happen, and generally, because we have gone a long way, and I think we have achieved many things. We have done many pilots. Now we have new members. We have Sander, which is also very enthusiastic in the team, and we have been now in the standardization phase. So we used to say that LDES is the baby of SEMIC, but now I think it's the toddler of SEMIC, and I hope it will get to a teenager phase. So here is Sander.
Hello, nice to see so many people. The room filling up. Yes, I think most people that are involved somehow in the LDES community already know me because I've been around for quite some time. But for those that don't know me, just come afterwards and I can talk to you about LDES for hours. But as other people will be talking today, I don't want to be talking about LDES myself today. I just want to get you a bit of context of this LDES session by zooming out and talk for a minute about what we're doing in the Interoperable Europe action. I mean, what we're doing in our unit. Because whatever we do is, since we had the Interoperable Europe Act a bit over a year ago that it went into action, yes, a bit more, time flies. A lot of the things, I mean, everything that we do somehow is anchored by this piece of legislation. And it brings, it's good to, if you haven't read it yet, you should. Because it gives the people that are here today a bit of a mandate to take action to work on interoperability. I think, well, we have the act, but it's a legal document, and it does what legal documents do, and it is legislate, but it doesn't really help you achieve interoperability in practice. And that is why we also have the European Interoperability Framework that puts things much more into context and makes it a lot more practical. And it is it is more the anchor of what we do in the unit, because legislation, fine, then doing things, well, we have the framework to kind of bind everything together with recommendations and of course the principles. And to kind of start this off, I would like to invite Emilia and Pieter to have to give a quick overview of the work that they are doing in the revision of the European Interoperability Framework, because we thought it was quite important to provide this provenance between the strategic part and then going down the lane of being more practical and operational with LDES. So without further ado, I invite you to come to the stage.
So I want to start with a quick question. Who in the audience knows the European Interoperability Framework, the EIF? What a surprise. At the SEMIC conference, almost everybody knows the European Interoperability Framework. When was it last revised? It was in 2018 was the last version, and that was in times where we had mainly the Open Data Directive and or the PSI Directive back then on there. And yeah, I mean, if you're now going to check the 2018 version, it's mainly about open data, openness, transparency, which are all good principles. But today we got so many different acts, we got so many different ecosystems, we got authorization, trust, and AI in the mix and so on. It changed today. Yeah? And when we are talking about sustainability, because that's the topic of today, I think the European interoperability has a big role to play. So I'm very happy to be able to say that we invited the best possible person to explain you all about the European interoperability framework and how it's going to advance. Because Emilia Stoshmenova-Du, did I say that correctly? It's okay? Okay, then you'll have to teach me next time properly, how to do it properly. But she's leading a team of experts on making sure that the European interoperability framework can be updated to the setting in 2026.
Thank you so much, Pieter, for raising the expectations so high. So I hope I will not disappoint you. My name is Emilia Stoshmenova-Du. I'm associate professor at the University of Ljubljana. And as Pieter mentioned, I'm chairing a wonderful group of experts, European experts. And since May this year, we have been working on the revision of the European interoperability framework. So why a next generation EIF? Pieter already mentioned when was the last time when the EI Act was revised, so many things happened since then. Something called generative AI, probably you are already fed up of listening to this word. Then, of course, we need to somehow include the artificial intelligence in the European interoperability framework. Another thing that is happening is really fragmented digital landscapes across member states. I was listening to the main stage in the morning, and if you were there, probably you saw a lot of excellent examples from the northern part of the European Union. It was only Poland and Italy that were from the southern part of the European Union. And the countries are the same, the member states are different, so the developments are really different, making the whole European Union very fragmented when it comes to digital transformation. Another thing that we have seen people are now expecting, this is also because of COVID. People now are used to digital services, they're using them, so it's not like in the past. Also the digital skills went a bit up, and people now are looking for cross-border services that just work. They don't care what is in behind, they just want to have services, public services that work. So who we are, the expert group? Sorry. This is who we are. As mentioned, my name is Emilia. Then we have Nadina, who is working as a rapporteur. You all know Pieter, one of the experts. Mats is from Denmark. He's also here at the conference if you want to find him later on. We have Yanis, George from Yanis is from Greece. George is from Portugal, Ruta is from Latvia, Ville is from Finland, and Katarzyna from Poland. So this is the group of people I've been seeing, except my family, most in the last couple of months. We are now at the phase when we really like each other, and we are very proud of the work being done so far. What is the goal of the next generation EIF? We want to clearly make everyone understand that the EIF is not just a technical framework. So it's not only about technical interoperability, which most of the people see it like that, but it's most importantly a governance instrument. It is also important that we want to have seamless and usable digital public services. We want to use a common language for public sector digital transformation. We want to make sure that the EIF is a catalyst for single digital market, and we cannot hide away from the AI. We want to use it as a foundation for AI uptake and responsible use. But most important of all, for us, it is crucial that we see interoperability for impact. Again, something that came up from the panel earlier. If you're only speaking about interoperability, people don't understand what interoperability is. A lot of times they cannot even pronounce the word. So they see it as a cost, they see it as a burden. But if you tell them what is the value interoperability brings, so what is the impact because of interoperability, then we're speaking about something else. What we tried to do with the next generation European interoperability framework, and you're very lucky because we have a whole panel session tomorrow on this topic, so you will be the first ones, except of the permanent working group, that are going to see some of our work being done so far. For us, it was really important that we make the change, that we move from we follow the rules, that we have the interoperability framework now, to we achieved measurable results. So we want to make sure that the member states who are going to use the interoperability framework, that they will be able to show how they achieved measurable results because of interoperability. The questions we were asking ourselves is, what value are we creating through interoperability? Because first, it has to be understandable for us if we want to make sure that other people will understand that as well. Then for whom? Is it only the public administrators? Is somebody else there? Are the citizens? And also, then another question, how do we ensure that this value is actually realized, measured, and sustainability, sustained over time? So this is what we did. First, we wanted to define who the users are. And we came up with this brilliant idea of naming the users ABC. So A stands for administrations, drafting legislation, and designing services. Then we have the businesses interacting with public systems. And last but not least, the ones who are really important are the citizens needing the services that simply work. We also defined 8 different stakeholder roles. So we have the public service consumers, we have the policymakers, legislators, then service designers, public service providers, data providers, ICT providers, and standardization bodies. We wanted to make sure we're not forgetting about anyone, but we also wanted to understand how these stakeholders are involved, are interacting, are engaged by interoperability. We have seen the feedbacks from the EIF from before, and a lot of time it was a criticism that it's very high level, it's not concrete, we don't know how to use it, and we wanted to change this, so that's why we came up with very concrete application scenarios. So everything we're building on is centered around 4 application scenarios. One is lawmaking, then policy making, service design, and solution development. We are keeping the principles. We have 12 principles. We will show this to the Interoperable Europe board next week. It might change some of the things, but at the moment we have these 12 principles, and as you can see, many of the principles from the past stayed the same. We have added some things that were not there. So Pieter mentioned that the current EIF is all about the open data. Now we're trying to make sure that we are including other things as well, and if something was redundant, to leave that out. But what is also important for us, it was when describing the principles, we wanted to make sure what is the rationale, why we're bringing this principle, then to describe what this principle means in practice, and last but not least, the implication. Also, the whole conference, the whole event here, SEMIC, it is about impact. So we wanted to really make sure what will happen if we follow this principle. What we did then for these 4 scenarios, if you remember, these are the scenarios, we have provided recommendations. But these recommendations are not high-level general recommendations, so this is just a snap how it looks like. We named the recommendation. We also named the stakeholders for whom this recommendation is, what interoperability layers are affected, what principles are affected, then what is the relevant legislation behind, and then if there are already any relevant interoperability solutions. We want to make sure that we are going to update the framework, all these documents that we're providing, so anytime new legislation will come up, new solution will come up, that it will be included here as well. Another thing that we did is a cookbook. We want to make sure that we will have more of these cookbooks, so this is just one for the member states. What are the simple steps to follow if you want to have interoperable solutions? It depends on how much time will we have, but we will like to have such cookbooks for different stakeholder roles as well. So I mentioned AI. What about AI? How to include AI? We are all aware that AI can do many, many things, improve semantic alignment, automate mapping and translation of data models, and so on and so on. But in order to use AI, there are some conditions that needs to be fulfilled. So it requires high-quality interoperable data. Do we have it? Can we exchange this data? We also need clear governance on national level, on European level, and so on and so on. And of course, we need strong ethical safeguards. So when discussing with the team, do we want to put a focus on AI's technology or not? We believe that we should not take care about the technology as such, but for us, the focus should stay the digital public services. We will see what will happen. We are also interested in your opinion. So I promise to be very short, in 10 minutes. I hope at least I met that expectation. But I will be here till the end of the event. So I will be happy to hear any questions, opinions. And I'm always available at my email. And I'm very sorry that I forgot to add the website and my social media accounts. But I'm Emilia Stemenova-Duch. If you just put my name in Google, you will find me everywhere. Thank you.
Thank you very much, Emilia. So Emilia will be around for feedback on the European Interoperability Framework. If you think like, but this should certainly have been in the EIF in 2018, please reach out to her. I'm also part of the group, so you can also reach out to me or to Mats, who's also running around, the Danish guy who also is responsible for SEMIC this year and stuff. Good. Then the next presentation is going to be by someone who we invited. It's our keynote speaker. That is about. It's correct, right? Yeah, that's good. Yeah. I was looking. Yeah. The thing is that we try to get from very high-level discussions, the EIF, towards getting more and more towards the technical aspect. So at the end, we'll be talking triples. At this moment, we're still higher level and trying to now slowly try to get to replication synchronization architectures. And when we talk about replication synchronization, there's of course linked data event streams. That's the best specification out there, of course. Although there are some competitors around, and I've seen a presentation at the Semantics conference when there was a guy that said like, but we do binary serializations for RDF, and we blow everything out of the water, here are the numbers. And it was amazing. It was great. We don't need LDES anymore. Or do we? That's the topic of the next presentation. So we invited Pieter, who gave a fabulous presentation at Semantics, and we asked him to bring his presentation over here as well as a keynote for the LDES workshop. Pieter, go ahead.
Thanks. All right. Thank you very much, Pieter, for the very warm introduction. And I am Piotr. I am the CTO and co-founder of Neverblink. We are a deep tech startup from Poland. We specialize in streaming knowledge graph and streaming neurosymbolic AI technologies. And before I start, there are two things that you must know. Firstly, I did not ever expect to be invited to this conference. Actually, I was kind of low-key suspecting I would be thrown out of here after some of the statements I made about LDES in front of Pieter. So this is a testament to how open-minded this community is. So I am very grateful to be here. Thank you for the invitation. And secondly, I am a huge fan of monolithic applications. You know, just one component, everything in one place. But unfortunately, does this work? Oh, I don't think so. Maybe I am pressing the wrong button. Oh, yes, now it does work. Unfortunately, in life, we don't get always what we want. So sometimes we just physically cannot have a single application. Sometimes you have the server and the client. They need to be on different physical nodes. They need to talk to each other. Or maybe you have a whole mesh of microservices that need to be distributed because they are controlled by different people. They need to be scalable, or it's because of security or whatever other reasons. In all of these cases, we have these pesky arrows going between them. And these arrows are communication that must happen, otherwise the system is not working as a whole. So if you have the communication that is not efficient enough, you will have problems with energy use, efficiency, and the responsiveness of your application. So Google, a long time ago, relatively speaking, realized that, and they proposed one of the many solutions to this problem, that is turning objects in memory into a serialized stream of bytes, sending it over, and then deserializing it also to objects in memory on the other end. The protobuf serialization framework does this very well. It is a binary protocol. And still, after they applied that across their whole infrastructure, they still spent about 5% of all CPU cycles on turning objects into bytes and then turning these bytes back into objects. If we think in the scale of gigawatts, which is how Google operates, this is huge. And you will see similar numbers for Meta, for example. But they are doing this right. They have invented probably one of the most efficient solutions to this problem. But one thing is energy usage, cost, and environmental impact. Even if you are not worried about these things, you may be worried about this. Can your serialization keep up with the rest of your system? Or is it a bottleneck? Because if your communication is not as fast as the rest of the processing, you will have the system grind to a halt. And we will be investigating today a case study about the Nanopublication network, where this was exactly the problem. As a bit of context, I represent Neverblink, like I said, but the Nanopublication network itself is an initiative led by Knowledge Pixels. It is a Swiss company, and actually we have Ashley here from Knowledge Pixels, so you can ask him all about nanopublications. I am from Neverblink, the startup that I co-founded, and we specialized in streaming RDF, so we don't have that much to do specifically with nanopublications. We did this work for Knowledge Pixels. They are our customer. And what is a nanopublication? It is like an atom of knowledge. You have some assertion. It is often used in scientific context, but for example, you can have an assertion that says, I measured the population of Copenhagen and it is this much. I don't remember how much exactly, 600,000 something, I think. Anyway, we have the provenance that says how I got this information, and then we have the publication information, which tells us about how we made the nanopublication itself. The whole design is to make it as fair, that is findable, accessible, interoperable, and reusable as possible by design. And we encode this as an RDF dataset with a few named graphs and about 50 to 200 triples, relatively small. But we have a lot of these. This is an example of a nanopublication that I made. I say in the assertion that I participated in the SEMIC conference. It is a very nice, welcoming conference. And secondly, the assertion, well, I said that, so that's the provenance, and then the publication info is that I made this nanopublication. And this is how it looks in RDF form. Like I said, it is an RDF dataset. Here we have it in a trig format. So where do these nanopublications live? They live in the nanopublication network. It is a mesh of services that is decentralized. So the idea is that we can scale this as much as we want to make it a truly global knowledge network. And we have two main types of services: the registry that takes new nanopublications, stores them, and makes them available for retrieval. And then we have the query service that answers user queries. And of course, we have these arrows. That means communication. Firstly, we have the registries that must talk to each other to replicate new nanopublications as they are being published to each other, so that we have multiple copies of each nanopub. And then secondly, each registry is paired with a query service, and we copy all nanopublications from the registry to the query service so that we can use it in queries. The way this was implemented before we started looked a bit like this. We had HTML or JSON pages with links to the individual RDF documents that were stored in the trig format. So you had to traverse this kind of a tree-like navigable structure, similar to LDES, to get to the individual nanopubs, and then you had to download them one by one. So to access 60,000 nanopubs, you had to make over 60,000 HTTP requests. The problems with this is that the trig format by itself is pretty slow to parse. It is a relatively complex format. And secondly, perhaps more importantly, the repeated HTTP requests, they added up to a lot of overhead. The result was that we saw very slow replication throughput, which was impacting the business because when we had a new node join the network, it took a long time to replicate. And secondly, when we had a lot of new nanopublications being published, we had the risk that we would not be able to keep up. Secondly, we had the issue with latency. Just retrieving one new nanopublication required 2 round trips to the server, which is quite a lot. And so the network was slow to react to users' changes. The solution that we came up with is based on Jelly. Jelly is a binary RDF format that is based on protobuf, the thing from Google I mentioned before. Jelly itself is 100% open, so we have an open specification, and we have open implementations that are licensed under Apache 2.0. You can use them for whatever purpose you might like. And you can find all of these at w3id.org/jelly. And it is designed to be very fast to write. In Jenna, it is 2 times faster than N-triples, and even faster to read, so about 12 times faster than N-triples in Jenna. All that while being reasonably well compressed, that is about 6 times smaller than an equivalent N-triples file. And it is maintained by Neverblink. We made the first implementation, we designed the format itself, and we are currently the stewards of the technology. But like I said, it is an open project, so you are very much free to extend it and develop it as well. It has integrations for Jenna, RDF4J, Titanium, RDFlib, or also Python without RDFlib. There is an experimental community-led implementation for Rust that is actually made by the people from the University of Ghent. There's an integration for Neo4j even, and there is a CLI application that you can use to get started with it very quickly. And how it works exactly under the hood, that's a topic for a separate talk, I think. But if you visit the website, if you Google Jelly RDF, or you just go to w3id.org/jelly, you will find a full guide that tries to explain it in simple terms, and then there is the full specification that you can read as well. But in short, we have a lightweight, fully streaming compression algorithm. It has very nice properties in that, with regard to the number of triples in the file, it has absolutely constant memory complexity, and it has perfectly linear time complexity. What that means is that it is like computationally the same as N-triples, just takes faster to write. And we can use it as a drop-in replacement. Also, the maximum supported triple number in the file is infinite, because there is no theoretical limit here. One thing that is very important for our use case is that one Jelly file can contain one RDF dataset like usual, like in Trig, but we can also have multiple RDF datasets, like you can see here on the bottom of the slide. We call this a grouped RDF stream. So we have a dataset after a dataset after a dataset, and we preserve the boundaries between them. This is something that is not supported by any W3C standard serialization format. How we applied this to the use case? So the registry application, it consists of 2 containers to make it simple. We have the API application written in Java, and we have the database. This is MongoDB in this case. For each nanopublication, we have a record in the database. So for each record, we added a new field that stores the nanopublication in the Jelly format as a binary blob. And now when we get a simple query like, give me nanopublication number 4, please, we just take this blob and send it to the client, and we are done. Great. But we could do the exact same thing with Trig. So what's new here? It becomes interesting when we have a query like this. Give me all nanopublications by Tobias Kuhn, please. And this is a very common type of query for this service. One of the most common, actually. And we have to answer with nanopublication 1, 3, and 4. In the original approach, we would have to make like 4 or 5 HTTP requests, something like that. But here we can do better. We can answer this with just 1 request. The way we do this is we go to the database, we find the relevant nanopublications, and we take their binary blobs, the binary Jelly files, and string them together in memory in a streaming fashion. And then let's notice something like this. We have 1 nanopublication. Chances are it will define the RDF prefix, and the RDFS prefix, and the provo prefix, and a bunch of other things that will also repeat in the second nanopublication and in many others. In fact, there will be quite a lot of repeating stuff. So why do we send all of this when we can eliminate it? So we designed a transcoding algorithm that can merge multiple Jelly files in a streaming fashion and eliminate the repeating stuff so that the merged Jelly stream that we get at the end is smaller than the sum of its parts. But we still do preserve the boundaries between individual RDF datasets. So that's kept. And all of this is done in a fully streaming fashion, also sending this back to the client. So we do not need to buffer it all in memory. We just work on it as we go. And we can answer with any arbitrary subset of nanopublications in the database. We can also answer with all nanopublications at the same time, and that's actually very easy to test. So as a summary, the Nanopub registry now can serve arbitrary subsets of nanopublications as a single streaming HTTP response, and the query and registry services that are interested in these nanopublications, they just consume the stream, unpack it, and process each nanopublication individually because, like I said, we do preserve the boundaries. So to retrieve 60,000 nanopublications, we needed 60,000 requests. Now we just need one. What are the results of this? I made a very naive comparison. This is the original approach. It is a Python script that I wrote in like 5 minutes. We just take the JSON. It contains a list of all nanopublications. And then for each of these URIs, we go there and we download the trick file and then parse it using RDFlib. So this thing for about 60,000 nanopublications takes over 3 hours to complete. I made a similar amount of effort writing this, which took me also about, well, maybe 1 minute. But I just need to request wget all nanopublications from the registry, and then I pipe it into Jelly CLI, which parses the stream, unpacks it, and tells us how many nanopublications there are. And the whole thing, like including the HTTP request parsing and splitting and so on, takes 4 seconds. So is it a scientifically accurate comparison? No, it's not. You should not make comparisons like that. But the point of this demonstration is that it took me a similar amount of engineering effort to implement both clients. Like I said, less than 5 minutes. And the difference that we are observing here is on the order of 1,000 times. So I think this is significant enough. In practical terms, when we were profiling the applications, the services that are involved in this mesh, we went from serialization and deserialization being like 30 to 40% of CPU time to it being not present in the profiler chart because it is so fast that it doesn't even register. So we just stopped worrying about communication entirely, and that was the whole point of this. We can focus on the rest of the application. We also made a more accurate comparison. Here we discarded the HTTP overhead. This was done fully locally. We had a dataset of 10 million nanopublications that we first serialized and then deserialized within memory. So as you can see, for serializing, so for writing, Trig can achieve with, I think this was done with RDF4J, which is what is used within the nanopublication services. Trig can achieve about 650,000 triples per second, while Jelly in the compressed variant, more compressed variant, over 10 times more. And for parsing, the difference is even larger, with Jelly achieving almost 10 million triples per second. So that's as fast as you probably need it to be. You can also go to our website. We have the full methodology there, and we have the benchmark code and everything if you want to check it out. So this is a question that you may ask. Why not pipelining, parallelization, caching as alternative solutions to the same problems? Because we have had these solutions for a very long time. These are part of the web architecture. This is how you should solve it. The first thing is that these would be more complex to implement, especially on the client side. And if something is more complex, then it means it's more costly. And unfortunately, cost is a big factor when we are talking about real-life use cases. Secondly, if you do parallelization especially, you do not lower resource usage. You actually do increase it slightly, at least slightly. The overhead still exists. You are just hiding it by throwing more hardware at the problem. So if you are trying to minimize your infrastructure costs, you are not solving anything here. Secondly, it does depend on the client to do things right. And this is a philosophical question a bit. My philosophy is that APIs should be performant and easy to consume and secure and everything by default, and it should be very easy to implement a good client for your API. The reality is that clients are often implemented in a very lazy manner, and people do not want to spend time figuring out how to use your service. It should be easy. Secondly, thirdly, fourthly, sorry, I'm not that great at counting. Jelly can also compress data across nanopublication boundaries. So even if you did pipelining with Trig, you would not get this benefit. So we can reduce the overhead a bit here as well. And finally, Jelly, in our case, client-side caches wouldn't help because of the access pattern that we were seeing. The cache would be usually completely cold. So I think this is the main part that Pieter wanted to hear about. And I hope that you are also interested in this. What does it mean and what's next? A little bit more bragging. This is the last slide where I brag. Jelly can do many things. What I have just shown you is just one use case, a relatively narrow one at that. Jelly can also do live streaming over gRPC or any other transport mechanism, including WebSocket or Kafka. We can also serve static Jelly files over HTTP. You do not need an active server for Jelly to work. It can work with huge data sets. We tested it up to 200 billion quads on the OpenStreetMap dataset, and it still worked fine. There is no theoretical limit. It has pretty good compression, about 1/6 the size of the original in nquads. And you can compress it further with gzip or with ZSTD or anything else. And we can also record changes, so add and delete operations using a new addition to the Jelly family called Jelly Patch, which serves a bit of a different use case, but also kind of related. This is the question that I got after I first presented this, more or less. I'm paraphrasing this. Is LDES useless then? Okay, so before we jump to conclusions, I think it's good to stress that Jelly is a relatively low-level tool. It is mostly a serialization format. It is to a degree also a streaming protocol, but only to a degree. It is only a part of the stack, at least this is how I see it. Jelly, for example, does not cover stream indexing, provenance, time annotations, and many other things that are present in LDES. So no, it's not that easy to say. We will come back to this question in a moment. But before we do, let's step back and have a look at what really is at play here. All right, I have shown you a slide where I said, now it's 1,000 times faster or whatever, right? But if we even just applied Jelly by itself, you see in the row tests that just the efficient binary encoding can give us like a 10 times boost. Like, okay, 10 times faster is good, but it's not 1,000. So the other thing that is very important here is that we merged many HTTP requests into one. This is really the one place where we can get orders of magnitude speed up. The unique capability of Jelly to have multiple data sets one by one and preserve the boundaries. But can we do the same merging trick without Jelly? Well, technically, there is nothing preventing us. And actually, Pieter and his team have already thought of that quite a long time ago. This is the tree profile specification that more or less attempts at the same thing. The way it works, as I understand it, please bear in mind that I am not an author of this. This is not my work. Is that you have pointers to individual pieces of the RDF graph within the document, and this is how you know that this part is a part of one message, this part is another message, and so on and so on. The problem here is that there is no guarantee about triple order in the file. So when you process this, you have to buffer the entire file, read it whole, and then you only know if you have all the triples from the first message, because maybe there is one triple hiding at the very end. You don't know. So we are also here restricted with what kind of RDF we can use. I don't think it is possible to use entire data sets here, for example. And this would be required for some cases like the nanopublications. It would be so much nicer if we could have something like this, right? We have a bit of RDF, a few triples, then we have a comment, add message, and then we have another message, Then we have add message, another message, and then add message, another message. And then we tell the parser, oh, you just be careful with these comments. When you see this comment, that means the message is complete. You have received all of it. You are done. You can move to the next one. That would be so nice, in fact, that this was taken from this draft specification document that we are writing together with the University of Ghent. This is a little collaboration between Neverblink and Pieter's team. It is done within the RDF stream processing community group at W3C that was very recently revived. We have a task force that was started a few weeks ago, so this is a very new thing. And you are very much welcome to join the effort and help us shape it. There is a public draft that you can see as well. And with this, we are targeting a very broad range of use cases. Personally, I would like this to be the basis for all streaming RDF systems in the future, because it is very generic. So not just LDES, not just government data, but also industrial data, IoT data, and nanopublications, of course, as well. So coming back to LDES and Jelly, what do we do with that? Well, of course, it is an open question, and it is up to the community. It is up to you. But I can tell you what I think. I think that these two are very complementary technologies, and if we can employ them together, we can get, in practical use cases, we could get, we could achieve, now I got lost in my sentence, sorry. Well, if we deploy them together, we could achieve a lot of success in practical use cases. This is what I was trying to say. And there are many possible ways that this can be realized. I have mentioned the RDF stream processing community group and the RDF messages draft specification. So this is a great basis for further work. But aside from that, I can see, for example, Jelly being used instead of tree profile or maybe indexed Jelly file. Actually, we started discussing this just before the session. Merging and caching LDES with Jelly, this was also discussed just before the session, or live Jelly streams over WebSocket, or diff streams, so just sending the differences between different versions of a dataset using Jelly patch. I would like to close this with saying that we, that is Neverblink, we would be very happy to collaborate on these topics and more, anything that you can think of. We would be happy to implement new features in Jelly. We would be happy to integrate Jelly with other systems and provide consulting on our technologies. Also, we are very happy to work on standardizing this stack together with other communities, such as the LDES one. Thank you. Do we do questions now?
For a few questions, I guess we will get a lot of questions here. Matthias.
I'll get some water there.
So in LDES, we do have support for name graphs, sending along that in trig. I guess maybe my knowledge about trig is not sufficient. I think all triples within one name graph is kept together in the file. Wouldn't that make it possible to stream it then? Or is it that you want to have a very large file? Maybe if you paginate, then you could at least get close to the efficiency that you're asking for.
Right. So what I meant here that within the tree profile itself, so within one RDF document, you cannot have multiple data sets and preserve the boundaries of that. Is that correct, Pieter?
More or less, yes.
More or less. But with name graphs, you can, right? But I want entire data sets.
Maybe I cannot. Yeah. Their question is on. So if you have a trig file, is there a promise by the trig file to keep all the named graphs, the triples within a named graph, to keep them all together? So Matthias states that possibly from the moment that, because indeed you have the curly braces, right? So you can expect that to happen. But in fact, there is nothing in the spec that promises to group them. There might be at the total end of the file, again, the same named graph being opened again and be put there. So you have no promise of the order, so you really have to go through the entire file before extracting.
Thank you, Pieter, for the answer. Apologies for not understanding it right away, but yeah.
Are there any more questions?
the Jelly format as a serialization format, could it serve as a store that you could query?
No, it is not indexed, and this is done quite on purpose, because otherwise we would not get these computational, these computational characteristics, right? So it was designed as a fully streaming format. I think I skipped over the relevant part. Right, this it is a fully streaming format and a fully streaming algorithm. Like, we follow the precise book definition of what a streaming algorithm is. So we can work with just one triple at a time. This is very important if you want to work with huge files and you have limited memory, or you just don't know how large the file is. If we introduced indexing here, we would break these promises. There are formats that can do that, like HDT or CODTAS that was just presented at ISWC this year, and they will do that for you.
Any more questions? No, I think everybody's overwhelmed. They still have to reason about all the implications of what you just presented to us. In that case, I think we can move on to Pieter's presentation of what happened in the recent past in LDES standardization work.
Your part. Okay.
Yeah. Oh, you pushed further now. Oh, no spoilers. Yeah. Okay. Yeah. Great. Good. Hi, everyone. We've done a lot of work on linked data event streams in 2025. There was, I probably had, I think almost every night I was dreaming about how to solve certain problems. I woke up in the middle of the night in order to be able to then fix something, a comment by Ranko, for example, and to be able to handle that. But I want to tell the story now of what we did in 2025. I will start with the ambitions the ambitions we had at the beginning and whether we succeeded. So then what we did in 2025, we'll talk about the new features that are now landed in the spec and that we can start using, and then the ideas for the next steps. So on the ambitions, I think today what we see when building interoperable systems is that data publishers, they will often just end up publishing what they have. There's not always a standard available. Linked data itself sometimes is an annoyance, so we'll just put out some CSV files, maybe. So in the end, we see that these data sets that are being reused are being consumed by a whole ecosystem of consumers that also don't talk to each other, and in the end they redo a lot of work each time on their own system. So a lot of the burden here of data integration is really, or the burden of interoperability is really on the consumer in this sense. And what do we try to do with the SEMIC community and with the SEMIC LDES community is, of course, to try to alleviate a little bit of the burden of the consumer. And by asking the data publisher, could you please not just do a data dump? Could you maybe always provide us with the updates? And these updates, could you describe them with linked data? Because linked data helps us towards making automated alignments to our systems. That would really help us forward. But still, I mean, the data consumers still have quite some effort that they need to do. And with linked data event streams, we thought, okay, these updates, we at least have something that is really necessary, because we don't want to process just dumps all over again. What we also want to be able to have is to have a continuous stream of information that it's not a one-off, that we will always keep coding against it. And just like Pieter said on Jelly, that Jelly is not an indexed stream, because we first want to focus on the stream. LDES itself is also not an indexed way of going across the data. What we first want is to make sure that the data can travel towards another system, so that it can be indexed over there. So we try to focus on replication synchronization, so that everyone can set up the API that they want on their system. And this way we're fighting a false dichotomy. I like to use fancy terms as an academic. False dichotomy is something you have a choice between two things, and you think these two things are the only things available. But in reality, there are many more choices. And the false dichotomy here is between data dumps that often result in a replication hell, because what will happen? You will publish a first data dump out there. People will start coding against it. Will bring out a product, and will forget that they ever have to integrate with something else. Maybe a stream of updates somewhere, or maybe a new data dump that gets published. Because then, if you bring out a new data dump, maybe they will have done local changes to their file, and there's no process in order to update these things. So we certainly want to make sure that we, by default, are not coding against dumps, because this will cause a replication hell. But the other part of the dichotomy from data dumps, it would be the querying APIs, and that should be two, of course. Yeah, there's the PowerPoint mishap there. But the second part of the dichotomy, the querying APIs would be then, of course, we don't want people to replicate everything. Just ask the question on my system. The problem there is that there are so many different questions that you can ask, and there are so many different query languages that you can ask, that you won't be able to satisfy everyone's needs. In essence, we actually need multiple views. We want people to set up exactly the API they want. So this results in a maintenance hell as well, because what will happen? You will have set up one API, a Sparkle API. Yeah, we in the Semantic community love Sparkle APIs, of course, but then our Sparkle endpoints, and then 5 minutes later you get a phone call like, you're a geospatial expert. So you want the WFS or an OGC API? Okay, well, I'll set it up as well. And then again, a little bit time later, you get again a phone call. You would like an auto-completion API. Elasticsearch. Yeah, okay. Well, we also say. In the end, you will get so many calls that you'll be maintaining 15 APIs on top of your data set that all do a part of the puzzle, but not fully. And still, you will not have reached. You will not be able to have solved all the requirements there. And this is the maintenance hell, because you'll need to keep all those APIs online as well. You cannot just put them offline, because you promised to actually solve these questions. This way of explaining linked data event streams is the original ways, like what we explained starting 2019, I think, was the first time we mentioned linked data event streams. And then 2021, I made a quick blog post about it. I always forgot to publish it, and now recently I actually said, well, I'll actually publish it, because I just forgot to publish it back then. So it's available over there. In that, I want to make sure that, or by explaining it this way, I want to make sure that LDES is not a specific technology. It's not this specific specification, maybe. It's a way of thinking about data publishing, and whether you're using Jelly or whether you're using our specific implementation of LDES, it's fine, you know. I just want to make sure that people code against streams. And maybe LDES is actually just a vocabulary to talk about event streams. Maybe we should also just be able to describe what Jelly does in our system. The only thing is, creating vocabularies of streams, that's not too simple, but I'll get to that later on, or maybe during the coffee break. Now I think we're evolving towards data spaces, and data spaces put this extra layer on top of that. So we had the linked data vocabularies that alleviate the data consumers a little bit. I think now by bringing ecosystem managers in the loop, we're also evolving towards interoperable data spaces. And there's always this tension between what kind of thing do you start publishing at the source? Do you immediately also align towards CPSV or towards, do you immediately align towards a specific standard in a specific domain? Or do you first speak your own language at the event source, and do you then do some alignments? Well, I think linked data event streams can decouple this tension, and instead of making it an or story of I either have to prioritize interoperability and have to choose this standard that's out there, and therefore I have to dumb down my own data model, or I have to choose between just doing my own thing and disregarding any standards out there, but then at least I'll keep my riches. Over here, we can make it sequential. We can first do the rich semantics, closest to our own data model, but immediately we can also provide the documentation of, here are the alignments towards these other data models. And this is what I like to call eventual interoperability. We don't need to do premature interoperability by first making sure that we immediately, without even a business case, try to align towards the standard that's out there, because there are so many standards that we could align to. What I'd like to do is to have the richest information at the source, and then have alignments by an ecosystem there that then could be consumed by consumers in exactly the application profile that they would like to use by using the alignments that are made available through the ecosystem. And this way of eventual interoperability, I think, will align much better with the business goals. But also, I believe that LDES is a very good technology to make sure that this vision can be reached by putting the event sources, by starting there with an LDES. Good, we've been busy in 2025. What did we do? Well, the status in January 2025 was like this. We had still the same spec as in 2021. We didn't touch it a lot. There was a vocabulary with some normative text on how to interpret what an event stream was and how to get to the individual events of it. We had some properties that were really vaguely defined, like pointing to a timestamp. But what exactly does that timestamp mean? Can we formalize that? Well, that's necessary that we would actually have a standardization trajectory for that. So the status was that we had a living document. People could pull request things in there. There was no formal process behind it. There were 30 issues open on the spec. It was unclear who would maintain that, or who would solve these. And we had actually quite some implementations across tooling. We had implementations by Flanders and Flanders Smart Data Space, and these building blocks are now growing into the open LDES ecosystem, right? I think there's some maintainers in the audience as well of that ecosystem. If you want to have a minute, no, okay, that's fine. Then we have some tooling in TypeScript. We have some tooling inside of the RML ecosystem as well. We have some tooling by the company Red Pencil. We have some tooling to work with LDES in Solid, and we also have very custom implementations. For example, the Rijksmuseum did something, and so on and so forth. Good. So we needed to actually move this forward, because we actually saw that adoption happening. And what we did was actually the opposite of what Pieter said. Pieter said, we actually need very simple clients. We want very simple producers. We want very simple producers because we want more data to be available, and the producers, they were able to just put out a data dump, and now we will all of a sudden ask them to do something really difficult. No, that's not what we want, because the alternative was a full Sparkle endpoint. Whew. From the moment that your project ends, you're basically going to say, the Sparkle endpoint, I'm not going to maintain it anymore. It's kind of a really dynamic server system that needs to be kept online. So that were the options that we saw. So we said, we just need to go one up from data dump. We need to get rid of all the bad parts of a data dump. We'll call it a stream from now on, and that's what we want. However, if we make it really easy for servers to put out a linked data event stream, we're probably going to make it more difficult for clients to actually be built. However, what we want to do is to specify it nicely. So we want a really good consumer-oriented, backwards compatible, stable release of the spec. And we want to write a client for, we don't want to write a client for one specific server, but we want to have that loose coupling that a client could understand a lot of different ways of putting out a linked data event streams in many different paginated ways, probably. Something that Pieter also said, like, why would you do pagination? Why would you do parallelization and so on? Well, I think it had some merit, certainly in our system, certainly because we don't have a binary format where we can compact it a lot. Good, what did we do? We had a lot of meetings. So it started in April, where we had an onboarding session. We also had a community session on the 22nd of May. And then we started the standardization trajectory in 5 workshops. I mean, we planned first for 3 workshops, but then a lot of interaction happened, and we added 2 more in September. And then we are now the 25th of, that's correct, right? Yeah, of November, the in-person LDES workshop. So you're all part of the standardization committee as well now. Welcome. So what did we do still in 2025? Well, we had these 30 open issues. I said, the ambition is to get to zero issues. However, that's impossible if everyone keeps opening up issues. But we did close more than 30 issues. So we processed 44 issues, opened up a lot of new ones. Still today we're down from 30 to 20 issues, but still very interesting discussions ongoing. We used to have just one spec. We did a lot of splitting up these things, just like we also heard in the previous sessions, where there was a distinction between a vocabulary, an ontology, an application profile, and so on. Well, we also think that the separation of concerns in specification artifacts is really important. So we have the client-oriented specification, which defines how exactly to code your client. However, if you're not interested in coding up a client, you can also just say, well, for my thing, I also need streams, but I'm not interested in replication synchronization. Well, you can still reuse our vocabulary terms, because that's a separate thing out there. If you just want to build a server, well, based on the client-oriented specification, we also have a server primer now that tells you how you can implement your own server. And we also have now implementation guides. Implementation guides that says like, you're active in specifically cultural heritage, for example. Well, we have some documentation for you on how to handle that. And yes, we also have a JSON LD context. Thanks, Brecht, for adding that one to the list. Good. So the client specification, it explains how to build a client that's logical. Then the vocabulary is an overview of the LDES terms and their intended use. The server primer contains best practices, but remains domain agnostic. And then we also have the implementation reports, where we had already DKTP feeds, and today we're adding cultural heritage feeds to that. The PR has been closed by now. Good. So from the moment that you would have done an implementation of LDES, when you would have something like that, please do pull request a small document there. Copy the template from another implementation report, because that is going to help us to see how people actually what design choices they made in their system. Good, and that brings us to the features that we added to the LDES specification now in 2025. Well, we finally have clear semantics on chronological time versus version time, and even if you would be looking at the live stream, yes, these issues have been open since 2023, and yes, after 2 years, we are only finally now fixing these issues. And I'm more than proud that we actually are closing that issue, that we now have clear semantics on these timestamps. Also, we've added another feature proposed by Eben as well, to really not only rely on HTTP headers for saying that that a page is never going to change anymore. That's LDES immutable. We are supporting transactions now, which was a long-standing issue that was posted by Sander back in the days. We also have very clear state management defined now for clients, how they need to react on HTTP status codes. That's also not unimportant. Okay, there are so many different HTTP error codes available as status codes. What do they mean? Does it mean sometimes that you need to retry after a while? How much time are you going to leave between retries? These are all things that we now defined. Finally, also, it was first Matthias Palmer that brought this to our attention. But he said, like, how is it possible that in your spec you don't make a mention of named graphs? And now we actually put named graphs as the default way of handling enveloping and things like that. I'll show a couple of examples there. And I think also a really big change is that we have a new design for retention policies, which was also the pet peeve of Sander, in which Sander was saying, we need to copy the log compaction ideas from Kafka. We have a stream. We have a stream of data. So now, how are we now going to make linked data from that? Well, basically, I could have said that maybe I liked the keynote of Pieter. That was before I read I heard all the insults. So I should maybe said there was a dislike now. No, that's a joke. Okay, so this is a stream of likes basically. And now later on, Anastasia Sofou also says that she also liked the keynote of Pieter. Good. These are messages that need to be added on there. So we want now to just maybe put this in one file, maybe want to put it in multiple files, maybe want to fragment it somehow. But at least we are going to need to add some context to this to these events. But this would be the most simplest example of a linked data event streams. Something we added is enveloping. So now, if you would say like, I created a data set, well, now you can actually use a named graph to then include the payload of the description of that data set. You can include it there. This is something that was first brought up in the DCAT AP feeds work, but in general, it's something that is very useful to have, of course. And then here comes the timestamp for chronology. So we clearly said that if you want to indicate that it was that your work or your event has been published in the stream at a certain time, we don't say like you must now use a specific property in there. For example, provenance generated time, or maybe you want to use Dublin core created or modified, or maybe you want to there's so many different properties that you could use to point at the specific time that something was created or was put on the stream. So instead of standardizing one specific one, we allow you to describe what property you use. And this is what we do with timestamp path. You add it in the metadata of your event stream, which is just added inside the data itself. So it's not, I really dislike the word metadata. For me, it's just everything is data, and you should serve your data with your data in that sense. So now we can clearly indicate that this property is being used for the chronological aspect. This is how it was, or this is in the way that it came on the stream or appeared in the stream. We also have versioning and create, update, and delete semantics on it. So you can also point at, in the same way as with the timestamp path, you can also point at this is what it means when something got deleted. This is what it means when something got created or updated. So you can really point at these things now. These are also new things that were added. And we also have now a mechanism to say like, these events actually need to be processed together. You cannot process them separately, so it needs to be a transaction. You need to wait until all the the transaction is finalized before you can go forward. Also something that was mentioned during the DKTP feeds system, in which when you add a data set, you maybe also want to wait, or when you add a distribution, maybe first, you want to also wait until the data set itself was also added into your system before you make available the UI. Otherwise, people might see, if they just enter the page at a certain moment, that there's a distribution that doesn't have a data set and just hangs in the void. So in order to have consistency, we added the feature of transactions. We also added then, because this was the big discussion, because the chronological order, but what happens with out-of-order streams? There might be that I first publish version 2 and then only later add version 1 on there. So we also added the fact that you can have a different timestamp, maybe a second one. Maybe now we don't use activity streams published, but now we use DC terms created to point at the time at which that should be taken into account when you try, for example, to have the latest version of your system. I know that I don't need to look at AS published. I can just look at DC terms created in that sense. And when you don't have a timestamp, we also allow you to use sequence numbers now. So then we don't have a timestamp path because we have a sequence path, and we also extend that towards a version sequence path in that sense. So that's the complete overview of the new timestamps that were added. Good, then this is getting a lot. Oof, I underestimated presenting all the new features. Yeah. Yes, okay, I can do it again. So LDES has a way of working with hypermedia. So we paginate because at a certain point you're going to have too many events for one page. And then, of course, if you're synchronizing, you don't want to pull the same page all the time. So we paginate. And this is a very simplistic example of how you can paginate. You just start with a root file. And I mean, this is just linked data, so you can just choose whatever serialization you want. You can start with trig, you can switch to turtle, you can go to JSON LD, you can go to inquads and so on. Doesn't matter. So that's why I just included a lot of examples there. But you can point at different time states, and the client should be able to traverse that search tree now and find you all the data and also order it. If you want ordering, of course, maybe you just want to have a fast copy of everything, then order might not matter. But that's how a client is going to get a full copy by traversing all the systems. We have the status codes that now we say that certain redirections must be supported, that we also have certain status codes on which a retry must be done. We also have, you might implement something towards data spaces with a contract negotiation step or an authorization routine that you might want to go through. That's up to a client. We don't further do statements about that. There are other protocols for that, like the data spaces protocol, of course. But it might be an interesting avenue to look at simple open building blocks there as well. And we also have any other kind of error code actually needs to say that this LDES view is not valid at all and needs to stop. We also then have some couple of more features towards immutability and the polling interval. So this is also the link a little bit with DCAT. So we have a specific view, the root.ttl, for example. This is distribution of my linked data event stream, because my linked data event streams can be published using on multiple servers. Maybe also one server might have 5 different views on top of it. Well, so there's we use the you could say that this view is a distribution of your LDES. Now, what we introduced is now that you should not only rely on the caching headers in order to understand whether something is immutable. Now we also introduced the actual triple that you can say, look, 2022, that's of course immutable. You should never get that page again, and you will, or the client will then never fetch that page again. So in this way, in this example, you know that 2025 is the only file I should still update in that sense. And I can also say that, look, my polling interval is 3,600 seconds. So, so I will just keep polling for updates on this view every 3,600 seconds. So I don't need to do it faster because that's an indicated polling interval there. That's also a newly added feature there. And then the final thing that we added is on retention policies, where there was a big inspiration we took from Kafka, where Kafka says, look, you don't need to keep everything indefinitely. You can also just remove certain things. And if you're concerned about the versions that you still want to be able to take a latest version copy, well, at a certain time point, you can choose to remove everything that doesn't help you to create the latest state of your knowledge graph. And they define different time points. So also for linked data event streams, we decided to introduce these different terms in which you could say now, we abolished the fact that you need to combine different retention policies for different functions. We just introduced the one and only retention policy over here, where you can combine all these features to then say, look, this is exactly the data that we will keep on the server, and that way also have like log compaction in the system. These are all the features that we've added. And that has been a lot of work, but we're not done yet. I think for an outlook in 2026, we certainly need even better developer documentation, because better documentation will lead to better tooling, of course. And the tooling at this moment, as Natasha also said earlier, it's like more of a toddler phase, and we really want to get it into a teenager phase, where we actually do have tooling that doesn't give problems after a while of using it, or doesn't give memory leaks, or these kind of things that we don't have to care for that. So yeah, so we will try to make sure that we have better developer tooling also towards test frameworks. There's still the issue of the shackle shapes that we will publish over the next weeks, for example. And certainly further evolve the server primer, who's now still in its infancy as well. And maybe, yeah, already fast forwarding to the discussion that we can have afterwards. And I'll just put this out here as a possibility, but triggered by Pieter's talk as well, is that at this moment we have a really difficult to implement client. It causes the fact that we only have 2 known implementations of an LDES client, one in Java, one in TypeScript at this moment. And I hope that, yeah, maybe we can look at a more simple spec. I'm not sure. It's something we certainly need to look at about how we could do with different trade-offs, maybe that maybe we make it a little bit more difficult or a little bit more constrained for the server as well. That we still can build a client, but that's much easier to implement. And then, of course, I also have the note on RDF messages, because since I asked Pieter to be the keynote speaker over here, a lot of good things happened as well. We started talking and even created already a specification where the last pull request was merged even today, just before the talk as well. That, yeah, as Pieter already explained, I also see it as one really nice way forward of the start building block to make sure that LDES and Jelly can work together. But it doesn't stop there. We also already seen a lot of hiccups with time series specific data for data science specific applications. Where, for example, if you have a sensor and you have sensor observations, that for every observation you would need to spend about 10 triples to put it out there. While we try to come towards RDF time series snippets, in which you compress, or you compact is maybe a better word, like 100 observations into just one literal, and therefore you make sure that you have a lot less triples into your linked data event streams, while still just keeping the same kind of information. So over here we try to make sure that we can make also time series efficient in LDES and in RDF in general. And then is the big question, of course, should we add support for Jelly? That's going to be a big topic in 2026. Thanks.
Okay. Any quick questions for Pieter?
Yeah, my first question is, why would you use a literal for time series when you have W3C cube, where you can express time series? And my second question was, what about the resource endpoints being dereferenceable? And could you elaborate on that, where you see, we would like to see the resource endpoint being dereferenceable, and you did not talk about that in your...
Yeah, okay. So the first question was about RDF time series and why a cube? Why not just look at data cubes? Yeah. There's no right answer at this point. This is coffee chat. I have a lot of hunch feelings, and I don't yet have hard results. My hunch feeling is that it's much more efficient to use literals, but we're still performing the analysis, and I'm happy to give you access to our latest evaluation reports on that are unpublished yet, but we're submitting it to a conference on Thursday, in 2 days. So but we have promising results. So it's efficiency. The second thing is on resource dereferencing. I think it's a cross-cutting concern. I think I didn't talk about it because I assumed it was self-evident that you make sure that IRIs are dereferenceable. And there are many tricks to make sure that you have lightweight architectures to make them so. Yeah.
It's not clear to everybody that they see.
Then I count on people like you to point them towards
it.
Thank you.
Maybe a last quick question, if there is anybody in the room who still has a question on the recent history of the LDES specification. If not, we can move on to the presentation of Pavlina. Yes. Thank you.
My name is Pavlina Fragkou. I'm a team leader at the publication office at the European Data Portal team. And here you can see all of the contributors of this effort. I'm going to present you some piloting linked data event streams in the European Data Portal. But what is the European Data Portal actually? The European... Okay, so sorry. The European Data Portal they are not the updated versions of the slides. Okay, never mind. Is the first version. Okay, acts as a portal that gathers, provides open data information and publishes open data information. So the thing is that it tries to implement the different types of this open data raises also the need to publish open data also raises from the fact that it tries to serve different policies such as the European the Data Governance Act, the European Register of Protecting Data, and as well as the highly valued data set. At the current moment, it is provides around 2 million of data sets coming from EU institutions and 35 countries that are participating following the FAIR principles. So, since we have such a large number of data sets, what is the problem that we would like to solve? The European data. Okay, let's pause. Let's pause it. Yes, I will keep on speaking, yes. Okay, so what is the problem that we will try to solve? The problem is that the European Data Portal harvests on a daily basis metadata of data sets that originate from different sources. So as we have a large volume of data, and we need to consider about storage and maintenance that are factors that should be taken into consideration during harvesting. So the data volume is expected to increase, to raise. This is due to the fact that we have a change in different in the legislation, with the most recent one, the environmental legislation. According to the last adopted data union strategy policy, there is a change in also the embroidering of the high-value data set, and there is an ongoing effort that has to do with the European Register of Protected Data that is held by the public sector. So, what we are doing right now and how we harvest metadata. We have, as you can see in the harvesting pipe, we have an importer that pulls away all data sets from the source, and we did some transformation, and we have also the exporter that checks if updated of a data set is really necessary. However, deletion happens as a final step at the end, as a comparison between what we say the identifier. So what we really want is to make this process even simpler. What we would like is to have in this harvesting pipe two components. The one that is the importer that pushes events into the portal, meaning that it receives events and maps them to the harvesting pipe. And the exporter and transform them into LDES streams, and the exporter that receives the pipe with embedded LDES streams and maps them to the corresponding hub repository API calls. So we would like to go to this direction. However, we start experimenting a bit with the whole situation. What is the current status here is that we have only a restriction on what we can do, meaning that at the back end we can only create, delete, and update the data sets, but we have a problem on the distribution part, that on the events, that we cannot update events on the distribution part. So we are just patching just a set of triples, patching just a set of triples not possible at this moment. So the idea is to reduce the load of the harvesting pipe, only relevant changes to pass. The idea is also to reduce the complexity of the portal size, meaning to perform checks for an update or not, whether we have a triple hash only, and to have an update only if it is necessary, and only to delete only when we have a successful run and before comparison of the identifiers that takes place. So, at the moment, events are still collected and processed regularly, and is not immediately when happening. This means we are doing some caching instead. What we would like is to add one more step to check with 4 LDES metadata in order to reduce the harvesting only to new updated and deleted data sets. We would like to reduce the load even more by implementing smaller events, meaning for what is not done already for distribution and patches, and reducing the delay even more, meaning processing the events when they are produced, to make it more synchronous. And on top of, at the end, we would like to focus a bit on the history of the dataset. So we started doing some experiments, some piloting with the 2 member states. The first is Belgium, which at this current moment provides around 19,000 datasets to the portal, and with Sweden that provides right now around 23,000 datasets to the portal. So, while having those discussions about how to set up the pilot, we have some pre-testing preparation and some types of agreements. So, the first thing that we needed to take care of is how to set up the infrastructure. Decide when to conduct the experiment, in which environment, pre-production, production, other, set up a new environment, to set up the endpoints for both sites, and or to create a GitLab space to facilitate the whole exchange and the setup of the problem, the exchange of information. So, but we realize that it's not enough. It's not about setting the 2 points. We need a methodology. We need a commonly agreement between both parties. What we had to do at the beginning is, the first prerequisite was to create a new catalog that we are going to use as a basis for capturing all the events. We had to decide what will be the proper size of the experiments to transmit the first bulk of data. And during this first bulk of data transmission, we had to decide the way of the transmission in order to avoid huge CPU consumption, or to transmit with a way in a serialization or with delay in parallel streams. We said, okay, once we can submit the first catalog, but we needed to agree on several taggings, several ways of transmitting the information between 2 parties inside the graph. And we say how we also started thinking about potential problems, how to tackle graphs that are sent by the sender that might include black nodes or missing information, how we tackle this problem, and what messages we need also to create in order to capture this information and register it accordingly. We said how we will, what the type of information and the parameters we will use in the log files, how we decide on how using the same attribute values in order to agree on the information sent and receive. We also had the discussion on the order to consume the event streams, what will be the nature of the streams, how many dataset, distribution, services, so that we have a type of a variety. The expected outcome, how we will document the expected outcome, We also consider how we will have the Sparkle as a query skeleton to check the validity of the expected outcome, as well as things such as how to declare that the data set is absolute and the deletion action is needed, to what extent it only suffers to send an empty data set without any further information such as distribution coming to a certain agreement. Also, the fact that what we were sending, what we were receiving, are the RDF graphs, something else? So we thought about what about using each test case and to put it into a proper space, a GitLab or the GitHub space. So it has its own URI to be downloaded. To agree also the messages between sent by two parties, meaning that we define the error messages, how we identify an error, and how to report the actions performed by each test case into the triple store. The idea that was proposed is to create a log file each time a harvesting is performed. And points related to the format of also, we discussed about what will be the format of the log file, its content, that were left to be clarified. The next thing is that we had to tackle was to go into the data part. We had to say which are the test cases we would like to examine, what will be the successful ones. We created a list with combining data sets distribution with catalogs and services, and which test cases should fail. And we realized that we needed to document and demystify the information that is resides into the log files. This is the part of the discussion part. And then we said, okay, after we receive the event files, the event stream, though there would be some additional actions from our side, from the portal side, in order to translate the small change event into the actual graph, so that we update what the end user can see in the portal. And we said, okay, if we want, let's do it. But how do we evaluate the effort? How we say that, okay, we come to conclusion that it's worth using LDES technology. How we say, how we measure things. So we said that we identified that we need to provide some criteria and metrics in order to evaluate the outcome. A criteria definitely based on the size of the data to measure. We said that, okay, it will be interesting to see the time needed to receive the streams, meaning the reduced catalog, because right now we are every day we are receiving the whole catalog from each and every data provider. What if we receive right now reduced catalog? How we can count the number of modified data set distribution data services? What is the time that is requested to perform the translation of the events, and the overall time of CPU storage and gain compared to the initial process? For Belgium, we started with the initial catalog had 7,000 streams. However, we had a problem with the client. We couldn't harvest. We managed to harvest only the first 5,000 streams. Then we got 100% CPU consumption. So the same with Sweden, thanks to Matthias. We have a more documented approach about the methodology and the test cases where we will find the information. This page is still ongoing. It will be fed with more information. We tried also to do a preliminary test with 1 million streams, but then we got, unfortunately, the same error. We couldn't manage to consume the initial catalog, again, 100 CPU. We play a bit with an order mode to see if we can do it into time intervals, but again, we didn't manage. Long story short, lesson learned so far. Different problems may occur based on the technological implementation of endpoints. We need to also take this into consideration. We need a methodology. Apart from the technical solution that is provided by the LDES team, for those that wanted to experiment, go to a step further and experiment, we need some type of methodology and step and agree on the error messages, etc. We need also to perform a specific fine-tuning and parameterization for each data provider. And we are looking forward to the new version of the LDES client. I haven't created a GitHub issue. I'm saying it here. So there is a very interesting for us ongoing process. And by this, I would like to help all those people that are contributing to the pilots, even though Matthias is not looking at. Thank you very much.
You? Yes. Sorry for the thing with your slides. Any questions? Yes.
Hi, thanks for the presentation. And first of all, I would like to say that besides all the complications that you might be presenting, that is very inspiring, and to see the data portal functioning and being able to perform Sparkle queries and get data sets from France and etc. And it's really good to then be able to go to the data portals of their own respective countries. My question is if you're seeing kind of the same approach percolating or being similar kind of approaches being developed in other data portals and other data spaces outside the public sector. And I'm asking this coming from the research data space, where I don't see much these similar visions coming into practice or in ambition.
I don't have the knowledge, I cannot exclude it, but I would like, to be honest, to have more, to go a step further into the experimentation, as we usually do in the publication office. When we have a good case, we publish a data story about this. So if we manage to have a more tangible result, I think we will propagate the information, which may be useful to other areas, such as the research data space, as you mentioned.
Thank you. Yes. Thank you.
But you can take a step forward and ask for some pilots if you're interested. I mean, if you want to test the technology and see moving towards the direction, you can make the first step. We will be happy to support you. Any more questions? Okay, then we should move with our next speaker. I will ask Arne to come on stage, yes. Arne from National Technical University of Athens. So.
Laser pointer? Cool. Does anybody see this? No. Okay. Can I see everybody? Yes, I can hear myself. Great. Okay. I'm standing here because I wrote a little LDES server for the data that we provide at NTUA for Europeana. I'm working in the cultural heritage domain. That's the cultural heritage data space. Now with the newest terminology, and maybe I should probably say a little bit about what we're actually doing in this data space. We are collecting metadata, from cultural heritage institutions, museums, libraries, archives, whoever actually wants to provide data to us that describe cultural heritage artifacts. We collect the data, and because the people that provide this data are usually not of the technical kind, they send Excel sheets, JSON files, XML files, emails. whatever. So we have written a tool called MINT, Metadata Interoperability tool, that helps the people transform that data in a common data format that Europeana defined. It's called the Europeana data model. And that is actually an XML format that's really an RDF file. Okay, so that explains at least the title of the talk. I think all the words were in there. Okay, so the whole thing is going on for a long time. So I think I started working on Mint in 2008. I think I was like 15 then or so. And based on the Commission's funding scheme, there were projects over projects over projects, and sort of we're now in 2025, so over 17 years, there were projects dealing with cultural heritage metadata that people needed tools, Mint, to get the data to Europeana that actually collected that data and then produced a website to show it to the people. And in the beginning, the data model was actually not RDF, it was some other XML format that's loosely based on Dublin Core, Semantic Elements called. And ever since we started this, we're serving the data that we collect from the participating cultural heritage organizations, transform it to XML, and then we host it on an OAI PMH server, which is okay. I mean, it works, right? It serves XML files to people, and Europeana has a client for that. And since mostly only Europeana reads the output of what the people deposit in our database, we are basically happy. So no need for activities there. People upload all sort of stuff. I already mentioned that. Yeah, and when Europeana changed from the original model to the new model, it still was XML, and OAI PMH serves XML, so really there was not much for us to do apart from changing the target schema in our graphical mapping tool. Great, easy stuff. I said that already. It's mostly XML that has Dublin Core elements. There you go. Okay, so I could say, hey, I wrote an ELDES server, and the talk would be very, very short. So I'm saying a little bit about how cultural heritage data looks like. It's record-based, and with record-based, that's every data is record-based, right? I mean, every line in a database is a record. But that means every item that usually you find in a museum or in a gallery ends up being one XML file with an RDF outside tag and then some metadata inside. Somewhere in there, an important URI that describes what this item actually is. And some other stuff that will create complications. And that is the one cultural heritage record. But we are not exchanging, we're not exchanging record by record data. Usually what the people do is they upload 10, 100,000 records. And that becomes one data set that we then treat as one unit. So it's actually collection-based, you could say. There's more structure to it. Some organizations have more than one collection, and Mint serves not just one sort of user community. We have split, again, based because of funding policy from the Commission, the whole system into topics. There was a funding round for fashion-related collections. There was a funding round for museum-related collections, and so on and so forth. So we ended up having, over the years, I have created 15 or 20 Mint versions or so. At the moment, we are at 5, I think. Yeah, cultural heritage data, it comes out as EDM when it's done with our tool, but it comes in as anything but. Yeah, I mean, the people that actually can serve RDF data natively, they don't need our tool. They can go straight to Europeana and send the data there. We are the people that help the little ones, the ones that don't have an IT department, the ones that don't know what XML tags are, and that make basic mistakes in creating JSON files. Right? So, but we are not perfect either. I mentioned that we started in 2008. I didn't know what a proper URL was in 2008. So we have IDs that say 1, 1, 2, 2, 3. I've seen that one as a URL in my XML files. Obviously, that's not necessarily data that goes into RDF lib kind of triples, right? It doesn't fit very well. But it's XML, it's valid XML, so if you throw it in OAPMH, your partner can come and harvest it, and nobody said anything for years. This data is there for 15 years, no complaints. Obviously, there is some magic happening, right? Europeana comes, harvests the data, says, that doesn't look right, but it's everywhere. What do we do? And then they make their own magic, they sprinkle some dust over it, and then they have URIs in their database and never say anything to me. Hey, you made a mistake there. Nope. So one particular characteristic of our data that's potentially has relevance to LDES is that our tool allows people to publish data to Europeana in one go. Here's my collection. And they can say, oh, I want to change my collection. What they have to do is they have to go and say, no, I don't want you to have it anymore. And then change. Here's my new collection. And it's everybody's guess whether they're related or not. They could have changed the IDs of all the items in there. They could have done whatever. So we only have adding operations and delete operations. We don't have any changes because we don't know when changes actually happen. Yeah, and this one I explain in a minute. So a record in EDM is not, oh, yeah, I have a subject here, and here is all the stuff that belongs to it. Nope. So there's many subjects in there. There's one main subject in there, but there's no magic way in saying this. And of course, I don't have a triple store. I have a relational database with XML files in it. I don't see triples. Technically, I don't know what triples are. I mean, I know what triples are, but Mint doesn't know what triples are. So LDES, how does this fit? Okay, so you have to see a little bit of XML. So this is the XML that usually comes at the end of the process. Lots of Dublin core stuff. The important stuff is we have one file, that's one tag that's called provided CHO, and the URL. And as you can see, there's already spaces in there. How did that happen? Don't belong there. Anyway, so there's this URL. But okay, so this is the main part of the data. From there until, okay, more than this. But unfortunately, it's not over there. Second part. So here, this is not part of the provided CHO anymore. There are web resources. That's completely new, you could say, subject URIs. And there's no way to say, at least from the LDES point of view, what is the actual record here? Is it that one? Is it the provided CHO? So I talk to Europeana and say, hey, when I send you something with LDES, the provided CHO URI, that's your record. And everything else, it's just fluff that comes with it. But unfortunately, that's probably a problem with the LDES specification and the client specification. Anyway, so this is one thing. Then the other thing is, this provided CHO is packed up in an ORE aggregation. I don't know why. Which is another URI that I don't know what it's used for. That was the data model. And so we made the files like this, but it's another subject URI that's going to be in the record, in the triples. Could be the main URI of the record, but there's no, well, we have to agree on basically what's the record. Here's another example record that shows more of the problems. Here's a nice RDF about. Great. And unfortunately, lately, the last 5 years, Europeana has added something to the Europeana data model that's extra attributes here. And whoever knows RDF knows this is not RDF anymore, right? This is something else. This is XML, but it's not RDF. So what do we do? Okay, for that part, the solution is, I don't know what to do. I remove it. So, and more stuff. What's the problem with that one? Yeah, I think it's again the problem that we have loads of subject URIs. Anyway, so why would we start using LDES? And the answer is not so sure, actually. I mean, OAPMH works for us, right? And as well, you can put date ranges in there, so you can sort of say, oh, I only want the last 5 months of data, or last day, or whatever. It does XML, so I don't actually have to deal with all this triple stuff problems that I just described. I just put it in there. That's a good thing, that's a bad thing as well, because I obviously delivered a lot of not so great data to them. But here's the key point. There is an API to learn, and every time I want to check, did I publish this? I forgot how to use OIPMH. So I start typing in the URL for the OIPMH that I want to harvest, and then I realize I forgot half of the parameters. So I Google OIPMH, or in the latest edition, I ask some ChatGPT, hey, can you give me please the invocation for OIPMH so I can find the right page with my record? And that's kind of annoying. I realize that's annoying. Now that I know there is potentially an alternative, yeah, and of course, if you distribute RDF, why not use RDF for this, right? It's like if you write a C compiler, you want to write a C compiler that compiles the C code that it's made of, right? There's a programmer's feeling that you should stay in your technology somehow. I don't know where it comes from, but we all have it. And of course, the LDES pages are technically machine readable. Nowadays, it has to be said, everything's machine readable. You have a page, you throw it in your LLM, it understands it. So that argument is kind of maybe becoming obsolete. But I said the API thing, that's definitely something. Okay. So how do you write the server? I'm not very good at reading the specifications. Sorry, Pieter. It's not your fault. It's all the specifications. It's not yours. So, and especially this picture said, I have no idea what to do. But it's not that bad. I mean, I've read the whole specification. Now that I have sort of collected experience, it's more readable, actually. Yeah, sort of. There's this saying, if you have understood the device, then you will probably understand the manual later on. And it's kind of this kind of thing. I wrote the server, and now I'm having more of a feeling that I can understand the specification. But that was the option 1. Option 2 was, there's already an LDES server existing. Go and steal from there. So, or now if you are in my situation, you can go and steal from my server. I'm totally happy with that. And of course, you don't get it right first time, so you send a mail to Pieter. Hey, Pieter, can you check my server? I don't know if it's working. Yeah. And then he'll tell you, no, it's not. And then you improve it, and eventually people stop complaining whether you're finished or whether they're fed up with you. I don't actually know that yet. And this is how it came about. So, some details for the cultural heritage domain. I already hinted at them. The URIs are crap. So I needed to fix them. And what I did is I removed all the characters that looked dodgy and made a new URL out of them. Hey, problem solved. The stuff that I can't deal with, I throw out. Yay. But Europeana has promised to give me a better data model where this is actually still RDF legal and I can transmit the information. So we're iterating slowly towards a moment where this can actually work. The multiple subjects, again, we haven't found a way to do this apart from talking. So I go to Europeana and say, hey, Europeana, sorry, this record has multiple subjects. Take this one when I send you a delete message. Because for the delete messages, you only send the ID, right? You don't send the event ID, you send the ID of the thing that you want to delete. And which of the 20 URIs in there is the thing you want to delete? So we agreed on one, problem solved, but I'm not sure Pieter's going to be happy with that one. So maybe we have to improve on that. Yeah. And then the events thing, not relevant. That's one thing that was puzzling to me from the specification. Now when Pieter has explained it, I understood it, because I've written it once now. But before, there is the event URI, and then yes, event metadata, like, oh, this is the create, this is the delete, this is the timestamp path, this is the version path, this is the object names path, whatever. And then suddenly there's a graph name that's exactly the same name as the event. Why? I mean, now I understand why. So it's the same thing, right? It's data that you want to submit, but it's not the same thing. One is the subject of triples, and the other one is the whole graph. So anyway, I understand it now. You understand it now too, I hope? Okay, and can we go to the next slide somehow? Okay, and this place, there would be the demo, which will not happen because there's no cable here for a demo. So But I was clever. I made some screenshots. So this is the LDES server that I wrote. We have at the moment serving 8 so-called aggregations of cultural heritage data. They're all sort of based on projects that happened in the past, people with a common interest. Behind all of these aggregations, there's some interest group, a museum or organization that collects data from of that kind, and is sort of a steward for many organizations that deliver data of that kind. And I clicked on one of them. It's the photography collection, all new photographies with special technologies and whatnot. And actually, while I wrote this, I got, how am I with my time anyway? Oh, we have 5 more minutes, right? Okay. Each of these numbers on the left is an organization, a museum, a library, a university sometimes, that submitted some data. And you can see when this happened. And each of these organizations is one LDES stream. So we don't have one LDES stream for all the stuff we deliver. We have one LDES stream for every organization, every of the aggregation projects we have. So we have many LDES streams. I'm not quite sure that's the best solution. I could imagine maybe we can have one LDES stream and put all this in the metadata of the events. Anyway, we have not done it like this. And if you click on this, I wrote a little UI that actually covers the LDES server in a website, so you can click through the system. So this is the typical root page. You get your LDES event description. Let's go to the next slide. Yeah. And then you get relations, and on the root page, it's usually the years where it's separated by. So this is year 2025, 24, 23, and so on. So this had the only event was happening in 2023 in this one. And if you go to a different one, this is one of the leaf pages. You get again the normal LDES event stream triples that describe the event stream. And then you get the member entries. And then for each member entry, this is an event. And we only use AS create and AS delete in our server. The fantastic URLs that I made, and the date. And finally, here this is linking to the next page. And one example record. And this is one of these XML records in Trig, in one of these named graphs. And 50 of them will make one of my leaf pages, and that's the server. So the good thing is the whole thing is very simple to write. So, Pieter, very simple to write. Goal achieved. So it was 400 lines of, Flask code, 300 lines of code that makes LDES datasets in RDFlib, and 300 lines of Mongo queries that query my backend database for the OAI server, or the OAI PMH server, and that's it. And I didn't even write half of that. I just said to, what was it, Claude Code or something, hey, can you help me with this? And I really had to do very little fine-tuning on this. Europeana has written a client for that. The code's open. That was not the client you mentioned when you said Java client. OK, this is a Java client that Nuno wrote for Europeana. He said he can harvest my server with that. He's happy. I'm happy. And Sander gave me a generic Java server to use. And I have to say, just reading it was more complicated than writing the Python version of it. Sorry, so I wrote the Python version of it. And OK, that's the Python code. It's really, really simple. I mean, you'd say, oh, that's one root, right? You write your root description, and then that's basically the root page of my LDES server. You say which collection you are, and it's like 20 lines of code or something. It's really, really simple. So you don't have to be worried. If you want to make an LDES server, go ahead, make one. It's simple. Any questions?
Do we have any questions? Yes. Are you happy? Cool. Yes.
Okay.
You don't have to.
1, 2, 3. Yes. This is not a question, but a remark. I really appreciated your work on this pilot, and if you just go and check out the server that he implemented, it's actually a really nice example of how you can also make it user friendly to scroll through your LDES to click through the links and to actually see it working. So it's a really nice work that was done. That's it.
Yes. Thank you. Oh, that means coffee. Oh, okay. Sorry. Yeah.
I was wondering why you created your own LDES client, because that means that the LDES is also specific, probably, for Europeana.
Well, if you have seen, yeah, we have sort of tweaked the LDES a little bit. I mean, the only way to get around this multiple subject thing would have been to create multiple create events and then multiple delete events to get rid of one record, I think. I think. I don't know. Experts, please.
Yeah, I think the question was why Europeana, so why Nuno actually created his own client and why he didn't use the existing Java client, because Brecht is it, right? Yeah. Brecht is positioning like, but then probably this client is made specifically for your specific LDES and not for all possible LDESs.
So I talked with Nuno, the author of that client, and he made a very good effort in making it as general as possible. I think the reason he wrote his own one is because he wanted to interface with Europeana's backend servers, which I don't know if they're an LDES a triple store or whether they have another system. I think they have an ingestion system behind it, which further processes the data, and so he wanted to sort of channel the data straight into that one instead of into a triple store. But really, you have to ask Nuno. Should have put his email on it. Yeah. Okay, you can probably find out if you follow the link to his client. You will find Nuno. Yes. Coffee?
Coffee. Coffee.
Okay. Can I just ask everybody to just go back to their seats so we can continue? Can I just, hello, can you all just move back to your seats and stop talking? I know you have a lot to discuss, but we've arrived at the final part of today. I know everybody's super excited about linked data event streams and all want to discuss, and we have a few more interesting presentations for you. So I would like to invite Gert and Brecht to the stage to discuss what they have been doing with linked data event streams in the domain of water.
Yes. Okay. Hello. Thank you for having us on stage. We want to talk about LDES and why we use LDES in several cases. We will be mostly specific about the water data space case that we are realizing in Belgium. Well, we split it up in three things. Why do we do this? We have societal challenges, we want to stimulate innovation, and we want to improve services, especially for citizens. Societal challenges. So we want to, there are complex problems that we are facing, especially now we're talking a lot about water, so it's about climate change. How do we handle those complex problems? I don't know if you know this picture, do you recognize it? It's actually about the triathlon that was happening in the Olympic Games in Paris, where they jumped into the water. There was a lot of trouble with would they be able to start or not, and they actually had to postpone it one day. Why? Because there were a lot of rains in Paris, and actually their sewering overflowed into the water. So the water became too dirty to swim in. This is one of the societal changes that we are trying to tackle together with the cities. One is really, we want to make the waters swimmable again. This is one of the cases in Bruges. They have internal waters, and actually in the city they want to the citizens be able to swim in that water. Of course, we have another problem next to dryness. We have overflooding a lot in Belgium. We are a country with a lot of water, and we are quite low, not as low as the Netherlands, but still low. So we have a lot of flooding problems. And another thing is we have a lot of roadworks. So pumped up water is happening a lot because they dig a hole, they actually get into some water. They have to pump the water away. It's clear water from the soil that's pumped away and is lost. Those are three really societal problems that we need to tackle, and we're trying to tackle right now. How do we do that as a digitalization partner? Yeah, we go into getting data and trying to predict the data on these topics. But that's a complex topic because on one side we have a platform that we are working with the cities on, so where 3 cities are connected, and we have all the data from the city itself. But we need data regarding the overflow. We need data from Aquafin, which is our sewering partner in Belgium, actually in Flanders. So we need to have the data about what is happening in the sewer system. We need data from the drinking water companies, because we need to know how is it with drinking water. Do we need to handle something there? Because, for example, a lot of those, like Waterlink, is taking water from the open water areas and is purifying it. So to know what the water quality there is quite important. We need info about what is the water levels in all our systems. So we have water info, which is from the VMM, who's actually giving us the water info data. Of course, we need data about the water quality from the VMM itself. So they are having multiple sensors all over Belgium, quite high quality sensors, but we need to get the data in. And then at last, we also need the weather. How is the weather handling? What's the prediction of the weather? Because all those things impact on what is the in the 3 cases, what is the water at that moment. So getting all the data is really integration hell. And that's also why we went into the LDES spec. To be honest, not everybody already implemented LDES. Those are the systems that we integrated them, but Aquafin and Waterlink today are providing us an LDES, and also VMM is right now providing us an LDES service. So that's where we're integrating with today. But to showcase, I do hope the movie works. What an overflow is. This is an overflow of a sewering system in Belgium. You see this wall. On one side is the open water. On the left side, there is the reservoir. There are sometimes rats that are walking in those overflows. But if you have a heavy rain, you will see that it starts overflowing. So water from the reservoir, because it's too high, comes into the open water. Goes heavy, can go much heavier. So in the end, a lot more water comes into the open water. In the beginning, it's quite dirty. When it's heavy overflowing, it's less dirty, but still it's from the dirt reservoir itself. So then it goes. And after a while, it stops again. Sometimes it can happen that water goes back into the reservoir if there's no valve stopping it. You have ducks that actually get into the reservoir. We don't stop that problem, but still, it's another problem. But that's actually the things that we are monitoring. There are, at this moment, about 9,000 overflows in Belgium that we are monitoring. 4,500 are owned by Aquafin. 4,500 other ones are owned by about 80 other organizations. So we have 80 organizations that are tackling these overflow sensors that we need to get the data of, because that's actually what is impacting our water quality. So it's quite a difficult challenge to tackle. What did we do at the Aquafin side? We actually set up the LDES server, which was in the previous talk talked about, was a little linked about, but the LDES server from Digital Flanders, we have set it up at the side of VMM, Aquafin, and actually also on the city side. So this is the way that we publish the data. On the Aquafin side, we also have set up the LDES client, and we are publishing towards the Blue Portal. One of the things is that we also were able to test the LDES server quite heavily, and we were able to fix some of the bugs that were in there. So we are getting more and more on a production level, but this is already running in production right now. So this is set up, and actually the Blue Portal is available to the large public today. Then another thing, this is just the overflow sensor, getting the data to other parties like us to be able to do something with that data. What we want to do to get new innovation, we want to do new things about it. And that brings us to what I said about Roeselare, the city of Roeselare is a very small city in Belgium. That actually has a big problem with overflowing. If you look at, this is Roeselare on the water map, you see a lot of these little streams that when it rains quite heavily, the whole city overflows. They built, of course, these new systems to hold the water, but they also wanted to be able to predict the water levels. This is the city of Bruges, and there they actually want to be able to swim more in the water, and actually want to warn the people when the water quality is bad, have an automatic system about it, but also we can steer the locks of the Bruges internal waters. So if we measure that the water quality is bad, we can open the locks and water flows faster. There's one issue there. We need to measure the water level quite well, because a difference of 10 centimeters means that tourist boats can float or not, because the Bruges are quite small. So we also have to take into account the water levels there. And now I'm giving the word to my colleague Brecht, who's talking about.
Thank you. So why should we do LDES? I think one of the main things is getting social value by improving services. I will give some examples. We implemented LDES, and that it directly gives return to citizens. The case here is from Westour. It's a governmental organization in West Flanders province in Belgium. And they are focusing on getting the touristic information towards the citizens or tourists that want to visit the region. This data is used by cities that wants to promote their B&Bs, their local attractions, or like musea that want to reuse the data, etc. And these are examples of consumers of the data. So they repackage the data for specific target audiences, like this one is specific for a specific website for a sub-part of the region around the city of Bruges. The other one is, has a target audience bicyclists, so that wants to make a route in the region. And this is an example of a city that reuses the data to promote its B&Bs and hotels, etc. So a bit of architecture. We were also enveloping the data as a graph at the same time as the DCAT back in the day. We didn't know it of each other. So at the back we have a triple store where each change is represented as a member internally and packaged in a named graph. And there's a back-end, front-end on top of the triple store. This gets published as an LDES. And then the idea was to not have the maintenance hell where they have to provide multiple APIs for the consumers. No, everyone can set up their own custom API. Here's the LDES, you can do whatever you want. And it's provided through Docker containers that are publicly available. But in the end, consumers still are more urged, like, yeah, still give me the API, can you host it for me? So it's a bit of both. It's completely open, you can do it yourself, but it's also hosted by Westour itself as a service at the moment to make it more convenient for the local cities and smaller organizations to reuse the data. Like in this case, the JSON API is used by the website builders to update their information, or a triple store is used to have a Sparkle endpoint for internal applications also. So together with Gert, we talked about societal challenges for the water case. We want to promote innovation like data-driven notifications for the people that want to swim in the rivers. We want to improve services like websites. This is not rocket science, but this really gives impact on the society. But what we're a bit seeing now is we're still, we want to do LDES, but how can we prevent that these LDESs are not silos on their own again? And for this, I think the next step for us is also to work together on basic registries. Like for the water case, we need the water segments as an LDES, because we can then link the other LDESs with the same base URIs and then have this connection. And also another part is basic infrastructure. We saw the presentation of the cultural heritage. They have their own client also. So we need to prevent that this client only works with this kind of server, that we have the different versions now of the LDES spec, now 1.0. So all these implementations need to align on the same spec version. So we still see a lot of work in the alignment of the infrastructure there. And community events like this helps to learn and listen to each other. So we're very grateful to be here and share these insights. Thank you. Are there questions?
Any questions for either Brecht or Gert?
Brecht, can you elaborate on the Jenna Fuseki store that you use?
Yes.
How many triples do they contain? You know?
There are like more than between 10,000 and 20,000, I think 15,000 products. And each product has, I think 100 triples maybe, something like that. But each version is also saved. That's because it's a member and it's a complete version.
And do you have an idea of the total?
Total scale, yeah, I should calculate it.
Because when we tried it years ago in the billions, it was not feasible.
Yeah, it's not in the billions range, luckily.
Yeah. Thank you. Yeah. Which spec do you implement for the water quality?
Yeah, it's the VSDS LDES server that is used here.
No, I mean for the model, for the water quality model that you use. Do you use SOSA or do you use another?
This is in SOSA, yeah, water quality of City of Bruges. Yeah. Yeah.
It's the same as the one that we created in Modala. It's the water quality model that we created in the project Odala together with Digital Flanders. I think you were part of it, and it partially uses it in SOSA as a.
No, it uses the ISO standard, and it is deleted. OGC asked the ISO standard to delete the whole.
Okay. Yeah. That.
Any more questions for? In that case, I think we can move on to the next presentation by Ranko, who will be talking about the things he has been working on.
So, thank you. That's the green button, I guess. Black screen. I broke it. I'm good at breaking stuff, sorry about that. What do I do? Okay, cool. Okay, hi, I'm Ranko, and I'm glad you're still here because, yeah, it's late and you're tired and you want coffee, and I understand. But I'm going to talk to you about a little bit about what I think, what I believe we should do to have LDES adoption. Okay, so really quick, who am I? Well, I'm Ranko Orlic, and I've been developer for the full development lifecycle, ranging from analysis up to the maintenance of systems. And actually, I came across LDES just a couple of years ago, 4 or 5 years ago. And the moment I got involved with LDES, I was because of a request for code that we got for the Flemish government, I was kind of immediately hooked to LDES. And it was not, I repeat, it was not because of the charming personality of Pieter. It was just because I really saw potential in this thing, really. I mean, it's a way to do data sharing in an interoperable way. Wow. You can have one specification, you can have multiple LDESs, you can combine them if you're using linked data, which by accident the thing depended on. So, great. So, as I said, I was a former member of the VSDS development team. Actually, my role was mainly analysis and testing and documentation and everything but developing. And I was a developer, remember? So, after the project ended, and that was end of 2024, so December 2024, the project ended for our former team. But I kind of got engaged with the tree community group and the LDES workshop. Okay, so we won the request for code, and we started creating what the so-called reference implementations. We created 2 things. We created an LDES server, which is an essential part, of course, of what you need in an LDES environment, right? Because you need something that will turn your data collections into LDES collections, or in LDES, or actually publish them, your data collections as LDES. That's what I wanted to say. So we created an LDES server Java-based, and we also created some additional data transformation components that we initially packaged for the Apache NiFi system. Now, it turned out that our initial customers, let's put it that way, our initial early adopters, they had a pretty hard time capturing the steep learning curve of the Apache NiFi system. So we also decided to make our own lightweight little workbench with the same components, okay? And the combination of those two helped us to experiment and to get feedback from our customers. And after a while, well, we kind of figured, that's it. This is it. Now everybody's going to start using LDES in our LDES server and our components. Unfortunately, without documentation, that didn't work. So we started creating documentation, reference guides, manuals, all kinds of manuals. And in addition to that, some examples on how to get started and how to use our components. So we created a lot of that stuff. But as I said, tragically, the team had to stop working on the LDES server and the other components at the end of last year. And since then, it actually went into maintenance mode. So we did some bug fixing and patching, stuff like that. But I was lucky, because I was able to start working on a different European project, that is the LDT, the Local Digital Twin Toolbox. And during that time, well, the goal of that project was to create a certification scheme and a certification network for the minimal interoperability mechanisms, the MIMs, right? And it happened that LDES was one of those MIMs, actually one of those mechanisms, sorry, for the MIM1, okay? And I soon realized, well, if we want to have LDES in there as a mechanism, we probably, in the end, want to go to certification as well. Yeah? So that you can actually claim that you're compatible with LDES specifications. So I started working on some underlying fundamental things like test suites and actually validation mechanisms. So just to give you an idea, these are the links to the components that we made. The first link is some documentation page. From there you can reach everything that we did with the VSDS components. The second link is a server, which is Java code and its reference manual. The third link is the same, but for the VSDS components. So the workbench and all the things that we created, all the transformation, data transformation components. And the last one is a lot of documentation, a lot of examples that I made, because as I said, we had a hard time selling those components to our audience, and we had it to do, well, we had to do something so that people would actually understand what it was all about. Now, during the LDT project, I still noticed that people really didn't grasp what LDES was about or its feature set. And although the specification was very clear, Pieter, still I found that I had to do this. I had to make a step-by-step guide, which is basically a very simple and easy to follow guide, taking you and giving you the basics about linked data, giving you the basics about tree and LDES, in detail, of course, LDES, and all these feature sets, right? And I invite you, if you're new to LDES, go check it out. It should help you get started and understand LDES. It doesn't replace the specification, it's just an addition, it's complementary, and it gives you more examples and maybe some practical tips here and there. Okay, so as I said, we need a certification at some point in time because we want to make sure that when we have an LDES server implementation or we have an LDES client, you want to make sure that they work together, right? So you can have specifications that kind of state what you should do, but you also need tools to validate this, to verify that they actually work. So I started working on some shackle shapes, individual shackle shapes for our requirements, because before I started doing this, I need to extract more formal requirements from those specifications, and based on those, I could make some shackle shapes to do the validation. Because that's one of the things that our shackle, our shapes constraint language, allows us to do, validate graphs. And it happens, LDES is, of course, a data graph. So you can find the links there. And once I had created those shackle shapes, I created an LDES, a shackle validator for both tree and LDES. And that was based on the Interoperability Testbed RDF validator. So I didn't reinvent the wheel here. We just used what was available. And you can actually put them there. You can run, by the way, you can run those things locally in a Docker container. If you're not familiar with Docker, it's just a lightweight way of having a mini operating system run on your system, so you have all the dependencies and everything works as expected. Great. Now, those shackle shapes and those that RDF validator will actually allow you to validate one node of a tree or an LDES in its isolation. But of course, there are some requirements that span across nodes. Things that say, okay, this is a relation, and the relation can only have, can have multiple outgoing nodes, but can only have one incoming node, because otherwise you don't have a tree, right? Now, how do you validate those things? Well, you cannot validate them in isolation. You have to request a number of pages, remember the relation information, and then immediately afterwards validate those relationships. And I created a small test suite to do exactly that using the ITB, again, the Interoperability testbed. It basically implements a very simple LDES client, just retrieving those nodes and doing the validation. Again, you can run it locally, it runs there as well. Now, ultimately, I'd like to host it on the pages, on the European pages there, on the Interoperability testbed, so that you don't have to download it yourself and you can actually use it right from the portal itself. Okay. Now, I'm really happy to announce that I've created last week and I released a first version of my own client, and it's a client based on .NET technology. Sorry about that. It's a server, excuse me, it's a server. Did I say client? Man, it's getting tired. I'm getting tired, it's getting late. So what I did was I created an LDES server that can actually help you get started really easy with hosting your actual data collection as LDES. It's fast, it's simple, it's documented, it's out there on GitHub. And the best part of it is you can actually put it in your own cloud environment, locally on-premise or even on your local computer, and test it out. Why? Because it's packaged as a Docker container. So actually the language doesn't matter. The reason I wrote it in .NET is because I'm just more familiar with that environment. I'm working on the documentation, but there's already a page to get you started. There's already some how-tos. There is a lot of reference information. But if you bump into anything, I'm already working on a lot of other draft material, so I can help you out if you have a question. The best part of it, it's free. There's a community edition, and that's released under the European public license. So you can use it. It's released now, and it will be released forever under EUPL, okay? I do have an enterprise edition that I'm working on, and that will just add some enterprise features such as better scaling, better observability, better cloud deployment, and stuff like that. But that's obviously that is optional. The open source community edition should get you as far as you like. Okay, cool. So what do I think is needed for adoption? We've got tools, we've got documentation, and we've got some test sets. However, they're not really final yet. I mean, we've been working really hard with the groups to create LDES version 1.0, and all of these things are a bit behind, which is logical if you know that Pieter wrote the last parts in September. So we still need to do a lot of work. We need to actualize some test cases. We also have to create tests for the upcoming server primer. We have to make sure that the client tests also ensure that clients and servers will work together, etc., etc. And of course, we have to plan for future certification at some point in time. It's way too early for now, but we'll have to have that eventually. Okay, it's your turn. Get involved, try it out, look at it. Please give us feedback. That's the most important thing. We need feedback. We need to make sure that we can actually make something that is practically usable and that will actually cover your needs. Thank you. Do you have any questions?
Do we have any questions?
I'm glad nobody ran away. Do you have any questions?
No questions.
Wow. Pieter.
So you got our hopes up. You created the .NET LDES server, which is really nice. How about an LDES client now for .NET? What's your opinion about that?
Actually, I like yours better. So what I did was, and it's very early, and I didn't want to mention it, but I'm actually putting my hopes on a Node-RED environment, where I actually took your LDES client and I wrapped it into a .NET Node-RED node. So basically, I've done the same for the Sparkle RDF Connect Sparkle stuff, and I also done it for just input and output. So at this point, I have 4 Node-RED nodes. They're currently only on my system, and I haven't actually. It's public repo for the time being, but I believe that your LDES client is sufficient, and will always be more up to date than whatever I can come up with. So
we'll add that in the README of the LDES client in TypeScript. We'll add Ranko thinks this one is sufficient.
That's what I said. That's what I said. Indeed. Any other questions?
Peep. Okay, since I went through this horror of writing my own server, what's actually the input of a generic LDES server, and what's coming? Okay, what's coming out is probably the pages with the LDES pages, but what do you have to shove in?
Well, that depends. Obviously, you have to shove in linked data. I was thinking about also allowing JSON, which you could then actually configure the system. It would attach a JSON LD context so that you can actually have linked data and do it that way. And that's one of the routes I'm thinking about. But as I said, I'm creating these Node-RED nodes. So the idea is that you can have a pipeline of Node-RED node, or an RDF Connect pipeline, or a different pipeline, a VSDS pipeline, and you can actually convert your XML, your CSV, or JSON, whatever, into linked data somehow. I've done that, like 1 million times already with the VSDS components, and I've also written about it in the documentation on how you can do that with VSDS components. But it kind of applies to everything. I mean, you always need to do some transformations, and which data you have. It really depends on which data you have. I mean, you will have to do at this point in time, I believe you'll have to do a manual transformation. By manual, I mean you have to define that transformation somehow, and you have to have tooling to do the transformations on the fly, of course. Does that answer your question? We can discuss afterwards. I mean, the server that I wrote has a lot of flexibility and a lot of potential on what you actually can ingest. One of the things you can do is you can put your members into a graph, and you can tell the server everything that's in a graph is one member, meaning it kind of solved your problem where you had multiple objects or subjects actually in the same member. All of that is possible, but I'd say check it out and talk to me after the conference or during the conference, and we'll see how we can solve the problem.
I think now, if there is no further, is there another question from Brecht?
Brecht.
Hi, thank you for your presentation.
Thank you.
Have you thought about fine-grained access, like group-based access to a certain LDES or attribute-based access?
No, because as is also the case with the VSDS server, I didn't think about, or I didn't want to have a server that has security at this point in time. However, it's a very good idea, and it's something I could implement in the future, I guess. Yeah.
Yeah. Something to be considered.
Yes, I will. Just put it as an issue in my GitHub, and I'll definitely think about it, because it's a good suggestion. Absolutely.
Any more questions? No, then I think after the link that Ranko made with the Node-RED data pipelines and how to wrap the components, I think Julian's presentation on RDF Connect is going to be a nice transition into running actual data pipelines with LDES.
All right. Thank you very much, Ranko, for setting the stage. So I will be talking to you about RDF Connect. So it's a framework, fairly recent framework that we are developing actively in our lab. So I am Leon Rojas, postdoc researcher at Ghent University. And it's a framework for the management and the creation of cross-environment and provenance-aware data processing workflows. So, of course, the link with Node-RED. I was not aware of it before Ranko's presentation, so that's something to look at into for later. But where do we start from, and why do we even put effort into this? So, in this presentation, I will try to give you just a very high-level overview on the what and why of RDF Connect, and also what is the link with LDES, because as you see, there is no LDES in the title in an LDES workshop, but I will get there. So the motivation on the work starts from very obvious observation out there in the IT landscape, where we see that pipelines are at the core of any modern data-centric system. So if you have seen the presentation throughout the day, every time there was a slide showing somewhat of some sort of architecture or some sort of describing a process, there was a sequence or a collection of boxes with arrows which were somehow describing, even though they might have not called it as such, but they were a sort of pipeline. So pipelines are crucial because that's how you move data from A to B. That's how you move the data that is generated or that is produced at some point into the goal or into solving the use cases or the needs that certain communities, certain domains have. Data pipelines, as I said, are ubiquitous. You can observe them everywhere. You can observe them in ETL or stack transform load pipelines for data warehousing. You can see it in data science. Scientific communities have invested a lot of effort into creating systems just dedicated on how to manage and execute pipelines so that their work becomes easier over time. Data integration, so interoperability, something that we do at this community at the heart, at the core, requires data pipelines. Machine learning, of course, I don't have to tell you, you need to gather data, you need to clean data, you need to transform data, and so forth, so that this can become embeddings, this can become models into predicting new data, and so on and so forth. I can keep on talking about where do you need pipelines for a long time. But the thing is that building and creating and managing these pipelines, it's very effort consuming, because in real world systems, these pipelines start becoming complex. And the engineering effort you need to put into creating these things oftentimes outgrows the actual effort that you need to put in the actual business goals of the data system. So you really need to have dedicated engineers, and nowadays even there are roles for that. So data engineering, and the term escapes my head at this moment, but there are dedicated roles for managing Kubernetes and managing all these cloud systems, just so that data can flow and so you can transform it and so on. But the actual people or the actual roles that take care of what is in the data, these are different things. So with these observations in mind, so we started, especially from our side, we started being motivated by the initial goal. Okay, if we go into the problem or into the effort of creating a pipeline for a certain goal, and in our case, we see it oftentimes we were faced with the same goal, which in our case is building, creating interoperability, integrating data throughout semantic technologies. So moving data from heterogeneous sources into a knowledge graph-based approach. So we have to repeat the same steps over and over, perhaps across domains with slight variation, depending on the type of sources, depending on the outcome goal. We need to start doing this over and over again. So, of course, ideally, we just put the effort on building, like the templating of a pipeline once. We go through the pain of creating and curating every single step in hopefully in a well-designed way. And then the next time we just could potentially or ideally reuse the same pipeline so that, yeah, the time the time to market, you could say like that, it's drastically reduced. So that's the first goal in mind that we had when we started looking into a way to create reusable pipelines. The second approach, the second concern we had, and here I'm borrowing a use case actually from the falls of Sirus, is, well, in practice we see that depending on what we need to do, there are certain tools that are better suited for certain tasks in different execution environments. So, for instance, you see, and actually today there was also similar, the procurement data space slide, where we're showing that the pipeline they were using actually NiFi plus Python. In this case, it was an LDES that was, the goal was to use it to predict and to apply machine learning model on top of the data that it was being published there, to predict the data, the water quality. So it's very close, and I think this is a use case from the VSDS, the water data space as well, but it was an early design. Probably it's not the same anymore. But the point here is that, yeah, you start to need combining things because machine learning tooling, I mean, the state of the art is in Python, but data algorithmics and so forth, probably, yeah, Java components are better suited. And you can see the same pattern over and over again. You might look nowadays like new programming languages pop up, Rust, for example, where system languages provide very high performance for certain tasks, and you would like to combine these things in a seamless manner. Like, there's no need to start writing scripts or reinventing wheels into how to connect these things. So that was the second thing. Cross-environment interoperability was the second thing we wanted to have. Something I mentioned, or forgot to mention there, the main motivation here is because, okay, we work with a lot of RDF data, and RDF implementations vary a lot throughout languages. So you have a lot of things in Java, you have good things coming up in Python, recently in Rust. You also, in our lab, we do a lot of web stuff, so we have a lot of stuff in JavaScript, and combining these things is not always trivial. And lastly, throughout the projects we work on, there's always, or there's commonly the need of guarantee provenance of the data. So you build a pipeline, but then this pipeline, if you don't have a way to document what it's doing, it becomes a black box. And you throw some data into it, it will spit out some other data probably, and you don't have a clear way to say, well, where is this statement coming from? Who said this? How it was produced? And if you see a piece of RDF data, for example, or a piece of knowledge graph, and you point to a particular triple, it's very hard to pinpoint exactly the moment or the time where it was created, because the pipelines that are creating these knowledge graphs are very complex and are actually potentially mixing or integrating a lot of sources. So that's provenance, having this aspect, and I think linking back towards Pavlina's presentation today, for instance, provenance is about not only showing how things, or where those things come from, but also about auditability. So when you execute a process of a pipeline and something goes wrong, you should be able to also see, like, okay, why it went wrong, which component actually failed, and which data was coming in and coming out the moment it failed. This kind of provenance, which is like more like metadata provenance, you can call it. Pieter won't like me after this, but it's also very important for engineering and to sustainability of the system. So that's a very important aspect we had. So these three ideas, or these three requirements, is what form our need for RDF Connect. Cross-environment streaming, and I call it fair because, okay, provenance is not completely, it's not everything about fair. Fair goes beyond that, but we want that RDF Connect goes into becoming a fair pipeline framework. But you might think, he's reinventing the wheel. There are a million frameworks out there that already do potentially all of these things together. So why do we even have, or why should we even look into RDF Connect? So one of the, or the main characteristics I would like to highlight about RDF Connect is that to the best of my knowledge, is the only semantically describe or framework that allows to describe semantically your pipeline and immediately act upon it. So it's actionable. There are many other frameworks out there you can see that have RDF way to describe a pipeline description, but what they do in the end is translate that into another format, that ad hoc format that internally does something with that, and so it's not actionable. So semantically explicit pipelines it's something that RDF Connect gives you. Another technical aspect, native polyglot architecture. What does that mean? It means that whenever we execute something, whether that's coming in Python, in Java, you name it, it always has native control. So whenever something goes wrong, when an exception is raised somewhere down deep in the code of a component, that's something we can bubble up to all the way to the higher layers where it can be controlled, it can be logged, it can be noticed. Can be traced. That differs from many, some of the, for example, other frameworks. Let me name, for instance, Apache Airflow, a very well-established framework. There is a lot of big community on that. They are mainly focused on Python, but of course you can find alternatives to run things from other languages, probably potentially with container-based approaches, so you can spin up Dockers. Those Dockers, those containers, even though you can make things work, these things become black boxes for the execution of the perspective of your pipeline. So that's something that doesn't need necessarily happen in RDF Connect. And finally, provenance out of the box. RDF Connect's been semantically built. I mean, it's on its own an ontology, and it's on its own an ontology that is extending one of the standards of W3C, which is Provo ontology. And it's a very simple model that already gives you all the power and expressivity of Provo to describe what happens and to describe both proactive and reactive provenance. However, yes, we are not. It's not the only one. There are other systems out there that deserve a mention. One of those is CWL. There is a full community. There is years of work. This is our communities that are coming from scientific communities, mostly bioengineering, and they have put a lot of effort into defining standards. They try to. There are communities about bringing workflows frameworks together. So there are so many approaches out there that they are trying to do an effort to come together. We actually, with RDF Connect, want to go to them and to become also part of the community efforts. And Arrow crates, this is also something from scientific communities, and this is something, actually Arrow crates is schema.org based, so it's also semantic, and some recent extensions achieve something close to what we see in RDF Connect, which they are, like the description become actionable. So these are, I would like to also share that you can also find similar solutions out there. So how do you work? How does RDF Connect work? How do you use it? I said I will try to keep it high level, so I'm not going to go deep into the details, but there is a website, there is a technical specification if you're curious on how it actually works underneath. These are resources online. There is a GitHub organization where many of the components we have built, but also other components are starting to be built in projects. And we actually have a very nice search functionality where you can find them throughout all over GitHub. So if you just tag your component with some RDF Connect tags, it's easy to find them. And very recently in ISWC, we had the chance, so the International Semantic Web Conference, we have the chance to make a tutorial about it in Japan. And it has a very comprehensive documentation on how to use it, how to step-by-step create pipelines and create multilingual pipelines or polyglot pipelines. So if you're interested, do check. But okay, so RDF Connect, how this is actually related to LDES. So one of the use cases that we particularly use RDF Connect for was to create and publish LDESs, because we were again and again into the, we have to now transform this data, we have to now run mappings or RML, or if we don't like RML, Sparkle anything, or whatever other approach there is to knowledge graph construction, and every time repeating the same steps. And I'm happy to announce that, for instance, the BE, it was supposed to be a Belgian flag instead of the BE, but there are a couple of LDES already that are running out there that are inside built with RDF Connect. There is the European Agency for Railways. They have a DCAT AP fit that is run with an RDF Connect pipeline. I will give a bit more details about it next. There is also the Belgian DCAT AP, which was mentioned by Pavlina before, that is also built with RDF Connect underneath. And there is also some LDESs coming from biomarine domain. In this case, the Flemish Institute for the Sea. They do have LDESs. It says mirrored there because this particular LDES that I linked there is built with RDF Connect, but is mirroring one that they have in their own premises that is not built with RDF Connect. They have their own in-premise solution, but it is a nice example of how to actually show that we have pipelines to republish an LDES with slightly different conditions. So, but other LDESs are being built at this moment. We have many projects where we are again and again trying to expand and to further develop this approach. And just to give an example, how does the pipeline look like? So it's a very simple thing. It's a set of steps where you see data flowing. RDF Connect, something that probably didn't stress enough before, is streaming first. So it's based on a streaming framework. Why? Because knowledge graphs are dynamic. They are being on the move. Data is being updated. We don't want one-offs processing because that means having to do diffs, having to deal with instead of doing everything, reprocessing everything once just because a couple of triples change. So we want streaming data. And if you do streaming, you can cover for batch processing. That's something that the streaming computational models allow. And in this case, we have a very simple pipeline. So there is a data dump that is compressed somewhere on the cloud, and we just fetch it. We decompress it because there is we have to deal with that. We do annotate it with activity stream vocabularies to detect whether something was created, something was deleted, something was updated, and so on. We add some metadata to it so that we can then create the data structures that an LDES needs, and we write it to disk. What is cool about this LDES? That is all of this is running as a GitHub action in a GitHub repository, and the result is being written down in just files in the GitHub repo. So we have a truly serverless solution here for us because we don't have a server. We're just piggybacking, or who's paying the bills is Microsoft with their servers, and we have an active LDES which we can be kept in sync with. So we did the same. We took the same pipeline and we went to ERA and told them, look, you can reuse this pipeline for your DCAP AP feed. But the difference there is that they didn't have a file. They had a triple store. So all we needed to do was to slightly adjust the HTTP query or HTTP request that we did at the beginning. We don't have to decompress anymore, so we got rid of that component and we just rewrite it. It's just changing one triple in the RDF Connect thing. And they could run it in less than half a day. They just could redeploy the whole thing in GitLab in this case. So it's a different system, just like need to change the configuration files from GitHub Actions to GitLab CI/CD, and voila, there is an LDES. And the previous one took us a couple of weeks into developing the different components, and this one took the guys from ERA half a day. So that was, we see like the value of reusability there as well. But of course, RDF Connect can go much more complex. You can build much more complex, and indeed, in fact, we did one again for ERA, but this time for the actual knowledge graph that they have, not the metadata, not the DCAT AP metadata. And you can see that it can get very complex, but it also allows for that complexity. So that's what I wanted to stress. And just to close also, what about, I mean, that's a lot about building LDES, but what about consuming them? So once you publish an LDES, but that's just the beginning of the story. The idea is that you enable others to replicate that data, then do something with it. And the typical use case for the knowledge graph is I want to ingest it in a triple store and start querying it, start building applications on top of that. So we built a pipeline for that you can just, that is run in Docker actually, and with a couple of commands, just download the Docker image and execute, plus some configuration file pointing to an LDES, and then your triple store. It could be any triple store. In fact, there we show a little benchmark on multiple open source triple stores. And spoiler alert, Virtuoso and Oxygraph are the fastest to do ingestion. Some others are not so good. You can see which one's there. But yeah, so these just two components there, and this pipeline just saves you a lot of work, and you don't even need to understand LDES for that. You just get your knowledge graph in your triple store, and you can start building your applications, and kept in sync with it, which is the cool thing. So what's next for RDF Connect, just to close? We want to be aligned with all the community effort that has been done before us. Of course, we are just not going to claim that we come with the perfect solution. We are better than anyone else. There's years of work on this, and we want to be part of it. We want to engage with them. We want to implement more features, so allow interfaces so you can monitor execution, so you can control, have user interfaces that allows you to design your pipelines without having to write code. That's something that we want to see. Very important thing we have in mind is to align also with the initiatives like the EOS Cloud, so the European Open Science Cloud. We believe that RDF Connect could contribute there into having a very standard or semantic way to describe and reuse scientific processes. And of course, we cannot not look at AI, because AI can then also help into designing and automating the way we can create these processors or these pipelines. All right, so that's what I had to show. So thank you very much.
Thank you very much. I have a first question for you. You were talking about processors and you have this polyglot architecture that allows you to plug in multiple technologies. Of course, these things have to communicate between each other, and they have to pass on RDF in between them. Have you considered using Jelly as a way to speed up the serialization and deserialization between those components?
Right. I think it's a very good question. So first of all, one clarification. There's not only for RDF data that we pass along. I mean, we use it a lot for RDF-based use cases, but we can have a completely non-RDF pipeline process, for example, CSV for a machine learning thing. It can also work like that. Now, second, the technical design of how we communicate the different components, it doesn't matter in which language are built, are based actually in a protobuf specification. So we use protobuf and we use gRPC on top of it so that we have a universal way of communication between the components. So correct me if I'm wrong, Pieter, but I believe that we are just one step away into hooking up Jelly in that for RDF use cases, basically.
Yes, you are correct.
Yes, thank you.
Are there any other questions for Julian? I think everybody's getting tired. Okay.
I was wondering, in that use case where you actually convert it into activity stream objects, how do you know whether it's a create or an update? Because it was a pipeline, and I kind of had the impression it was serverless and it was stateless. So.
No, in that particular component, because there is no requirement to be stateless. I mean, it's easier when you're stateless, because then the implementation becomes simpler for whatever logic process you want to do. But that particular component, it's stateful. Yeah. It needs to keep a memory to know what's been created or not. But yes, RDF Connect allows for that flexibility. You want to be stateful or stateless, it's possible.
Okay, cool.
Thank you. Is there Brecht.
Is retention policy something on the roadmap, or is it already implemented in the latest spec?
You mean the LDES spec?
Yeah, to do maybe have a pipeline that does the retention on the LDES server, or
that's a good example of something we can build with RDF Connect indeed. But yeah, I think that's also something that servers or LDES servers. I mean, in the case of serverless, you need to have something like that, but normally that's something like the server itself should somehow internally manage, I think. And we are seeing popping up new servers today, so. Ranko?
All right, if we have no more questions, I'll invite Anniko to give a short presentation of what is happening around LDES in the publication office.
Yes, thank you very much. So I promise that I'm going to be short. This is a lightning talk, so everyone is getting tired. End of the day, a lot of very interesting talks. And okay, here we go. So I am Anniko. I'm a team leader of the reference data team in the publications office. And in the publications office, we are dealing with as the official publisher for EU institutions in the field of law, data, and publications. So this is our triangle. We are publishing EU legislation, official journal, EU lex, and so on, but also general publications, and of course, open data. So you already heard the presentation from Pavlina from the Open Data Portal. In our team specifically, our expertise is in reference data, so in controlled vocabularies, and we are in charge of creating, updating, and publishing them. So here where LDES is going to come into the picture to support the publication pipeline. So what is the context and what is our pipeline? Also, Julian mentioned that in every single presentation there is a pipeline or a process, and here we go. So we have a set of more or less 300 multilingual controlled vocabularies, authority lists, thesauri, taxonomies, that we are actively and very frequently publishing and updating on EU vocabularies. So EU vocabularies is our official portal for the publications, which contains the reference data catalog. But how does it happen? We are updating them in Vocbench, which is an open source and collaborative tool for the creation and update of controlled vocabularies. Then we do an export. And then we publish, first of all, in Cellar, which is our semantic repository that contains not only the vocabularies, but also all the other content of the publications office. And then it is mirrored also on EU vocabularies, where you can browse, where you can download, where you can view and sort all of these data sets. And additionally, we also have another publication platform, which is called Shovoc. Shovoc is a component of, not a component, so it's coming from the same family of Vocbench, and it also offers an easy visualization and browsing interface for the vocabularies. So this is where it happens. We have a lot of platforms where we are publishing and even a lot of choices where to implement LDES. So what are the challenges that we are facing? In this current publication process, we have a very heavy publication for every small change. So we need to do a whole publication of the whole vocabulary, even though there was only one label update or one translation added. We also have a very limited support for the incremental change updates. And also it's kind of difficult for the consumers to see what were the updates, because of course we are publishing diff files and release notes, but it's not really user-friendly. So what are the reasons for going for LDES, apart from the obvious that we like Pieter, we like the SEMIC team, so LDES offers an event-based representation of evolving data sets, as well as it's designed for the incremental changes and continuous updates. It natively supports the RDF data sets that we have, and also it's an efficient distribution for the consumers. So it would offer a real-time consumption of the changes. So the idea is that we are going to publish the incremental SCOS updates from Vocbench. So Vocbench would trigger the changes, and then streaming the changes for deprecating or for updating or modifying the vocabularies or the concepts in the SCOS vocabularies. And like this, the consumers would be able to keep the vocabularies in sync. So, as I said, it would start on top of Workbench, which triggers the changes, the change events. Then there comes, of course, a shackle validation for the changes, because it has to happen. Of course, we need to be compliant to the existing restrictions and also of what has been already updated. Then the others generator would create the event stream entries, and the stream would be stored and exposed via Stellar. I will stop here because it might not happen in Stellar. As I said, it's only a very initial idea phase, so we haven't implemented anything yet. We are about to launch, so we are still investigating whether the best position would be to do it in Stellar or in Shovok, because we are publishing on both platforms. So it might be that in the first phase we are going to test it with Shovok, as it's a little bit easier to manage, and Stellar has a lot of constraints and also a very heavy and strict publication environment. But then finally, anyway, or the stream would be published on e-vocabularies or on Shovok, or both. So like this, on the portal, the users could subscribe for the changes. So what are the next steps? We need to launch first. So this is not even a baby phase, it's a conception phase that we are in. One authority table, so one small authority list would be selected as the prototype. And then we would test the incremental changes from Workbench, integrate it with the existing publication workflow, and then publish the beta LDES endpoint on EU vocabularies. Of course, we are very much relying on the feedback from the SEMIC team and also of all our partners who are using our assets from EU institutions. And that's it. So I think we are the new guinea pig, the new client for the next LDES pilot, and we are really looking forward to it. So we are very excited to test. Thank you.
Alrighty. I think we have one final presentation by Mantas on the Universal API in Lithuania.
Yeah, good evening. I see there are still few awake people, but I promise I will be quick and not torture you anymore. What I want to present is the Lithuania's strategy for basically data management countrywide and our plans to introduce LDES support to our currently existing changes API. My name is Mantas. I'm from State Digital Agency in Lithuania, and I work there as a lead software engineer. So the issue that we currently have is, this is the real data in Lithuania, that we have about 200 organizations and 400 information systems and 2,000 integrations between them. So we were given a task to add interoperability, both technical and semantical, in 1 year for all these 400 information systems. So we took the challenge, and our vision was to introduce basically universal API, and this is for data. Most people talk about metadata, but this is for exchanging data between all the information systems in Lithuania. This new API provides basic functionality like CRUD filtering, pagination, authentication, and so on. So that's our solution. Also, it provides technical and semantic interoperability, EU core vocabularies, and so on. And for event streaming, we created our custom changes API, which we developed before LDES was introduced. So now we're thinking about adding LDES support on it. So the solution to our vision, because we have a lot of institutions, and if they want to adopt UAPI, it would probably take a decade for this amount of information systems. So to speed up adoption, we created our universal data agent. Basically, all information systems can install this data agent as an add-on to the information system. This data agent connects to existing data sources and converts existing data to this UAPI with all the interoperability, semantic, technical, and so on. So that's our solution, and it quite worked. The main issue was not technical, but it was a people issue, because what we needed to basically describe or map data from physical data model to this semantic data model. For this, we did a 3-stage mapping. Basically, one stage is that each data steward from information system described the conceptual model of this information system, which is mapped to semantic core vocabularies. And then other people, custodians, basically described, mapped concepts from conceptual model to physical data model. And the result was logical data model, which uses concepts from semantic vocabularies and also connects to existing physical data sources, retaining physical data structure. So basically, what we mostly do is do data mapping. And for that, we created another specification based on spreadsheets, because people understand spreadsheets, but they don't understand all the complexities of semantic linked data things. So they basically do all the mapping on spreadsheet, and spreadsheet is also machine readable, interpreted by Spinta, and Spinta in real time, according to this data mapping specification on spreadsheet, converts data into interoperable linked data to be used. So for LDES compatibility, basically we have most of the components already in place. For example, we have we are versioning objects. Each object is assigned unique URI. Each object has a revision number. We know which object when was created, when deleted, and so on. We have changes API that basically does exactly the same as LDES, but also have pagination. So what is missing? The one thing that LDES expects whole object as event in the event stream, and our changes API uses patches. So that thing we want to do, but I saw that Jelly also has plans for diffs. So maybe this also adopts that, and we don't need to fix that issue. So that's one thing. And the final thing is that we need to just, in our existing changes API, adopt LDES output format. Also for big data, we are thinking about adding data fragmentation, because we already have issues for data, large data. So the current status, so currently we use this UAPI with almost 200 institutions and provide almost 900 data sets in this UAPI format. And what we are planning next is to add more semantic interoperability, because this semantic interoperability appears on the quality of data mapping tables. So people doing data mapping, and if they do not add this semantic information, so also UAPI doesn't have it. And also we are planning to add access to restricted data using smart contracts with row-level permissions and all the securities and so on for restricted data. So that was very brief overview. It has a lot more complexities in it, but that's it for now. Thank you.
Thank you so much. Just before I ask Pieter to wrap up for the day and to provide his conclusions of whatever has happened today and some final thoughts, I just want to thank everybody who has been speaking here today, because, well, you put in the effort of preparing, and I mean, we've been chasing you to provide your slides on time, and it does take an investment to prepare for a day like this. So thank you all. And that being said, I'll just hand the microphone to Pieter for some final thoughts.
I have a microphone on my own.
Pieter.
Not should I? Okay, no it does. Thank you very much. Okay, so I will just continue by saying thank you. Not only to the speakers today, but also primarily to all the people who contributed to the LDES trajectory in 2025. It was amazing to see so many of you there during the trajectory, to people contributing to the LDES specification, not only opening issues, but also joining the discussion and opening pull requests as well. This is amazingly appreciated. Also, just creating assets next to the spec as well. Also looking to you, Ranko, was great work to have the introduction to LDES and so on. And I think we're just like Natasha said at the beginning, that we used to be a baby, now a little bit a toddler, in the sense that we see more and more adoption across member states, across thematics and so on. I really enjoy this community. It's a welcoming community, as Pieter also said. Also because, I mean, we don't have anything to compete against. We're all trying to reach for the same goal of making sure that we have interoperable data sharing, that interoperability is sustainable, that it's not just a one-off, but that it keeps flowing once the interoperability is created. And I really believe that we have the right story to tell, or that we are telling the right story. We are moving into the right direction, so we are only going to head for the stars with the LDES initiative. At least that's the feeling that I have after today's workshop. Maybe there's still some baby issues with tooling sometimes. Maybe there's sometimes a low performance. But if we can may believe Pieter, we will solve all these issues also in due time. In 2026, we already have seen lifted a tip, thanks to Aniko, that showed a great pilot as well that we'll certainly take on in 2026. So there are more and more use cases that are joining the LDES community. And I hope that we also will be able to do a new trajectory in 2026 to also still make the spec better and better. So that's where I have the great honor of closing the first day of SEMIC. Thank you all, and see you again tomorrow.